Let's do some very quick Regents chemistry review with the most common questions that show up on the Regents exam. So we'll go by one topic at a time, and for each slide that you see, take a moment to pause and try to answer the questions before you listen to the explanations. So here we have our first topic about matter and changes, and here are a few questions. If you look at the first one, all matter can be classified as, you can memorize this little chart that you see over here. So matter is in general classified as either a substance or a mixture. And then substances are further classified into elements or compounds. So elements are the simplest type of substances, and then compounds are made of multiple elements, multiple different elements. So if you look at this chart, based on this, an element or a substance, they're basically the same thing because an element is a substance, so that is not your answer. Matter is not only classified as an element or as a compound, so the last option that we are left with, which is closest to the correct answer, is D. And then in the next one, it says which answer is correct for X and Z. So as we just said, X is a substance, and substance can either be an element or a compound. So, and then Z is going to be a mixture. So the correct answer here will be D. Then we have number 3, which sample can be classified as a substance. So once again, substance is something that is not a mixture. So we are looking for either an element or a compound. So if you look at your options, we know from prior knowledge that seawater, air, and soil, they are all mixtures of multiple substances. So the correct answer here is argon, which is an element, argon gas. Then we have which substance contains elements chemically combined in a fixed proportion. Please make sure that you have memorized this. This concept is on your fingertips. Whenever we have elements combined in a fixed proportion, this is referring to a compound. If we have mixtures do not have any fixed proportion. We can always change how much of one thing do we want to add in the mixture. But in case of compound, if you want to make H2O, which is water, we need 2 atoms of hydrogen and we need 1 atom of oxygen. If we change that, that is not going to be water. So we are looking for a compound in our options. So manganese, Mn, this is an element. Then we have strontium, which is also an element. Methane, this is something that you should memorize because methane is a very common compound in chemistry. So please make sure that you know the formula for methane. It's CH4. And then we have silicon, which is also an element. So the correct answer is B. And just a very quick trick, if you are not sure whether something is an element or a compound, you can always look at your table S. So table S doesn't have all of the elements, but normally the ones that do show up on the Regents exam, they are named in table S, so you can always look there to verify if something is an element. Then for number 5, which substance can be broken down by a chemical chain? So we are talking about something that can be broken down. So this refers to a compound. Now the reason why we only said a compound and not a mixture is because we are talking about separation by chemical means, meaning there is a chemical reaction that needs to occur to break down that thing. Mixtures can be separated by physical techniques. So physical techniques are things like boiling, filtration, distillation, all of those techniques. So we are looking for a compound in our answer, and once again, go to table S. If you want to make sure which thing is an element, eliminate those options, and so your answer here will be ethane, which is an organic compound. So this one is C2H6. Then we have which substance cannot be broken down by a chemical chain. So remember that when you see this question, the question is not saying which thing can be broken down by a physical change. That is not what the question is referring to. So physical change is absolutely not mentioned in this question. We are talking about something that cannot be broken down at all. So that means we need an element as our answer. So once again, use table S, figure out which thing is an element. So that will be magnesium in this case. Methane, ammonia, and water, you should ideally remember the formulas for these things. Methane, as I already mentioned, is CH4. Ammonia is NH3. That's your ammonia gas. And then water is H2O. Right, moving on. Here are some more questions from this topic. So if you look at number 7, a sample is composed of 2 different substances that can be separated by using filter paper. So this sample can be classified as, so when we are using a filter paper, that means we are using a physical method to separate something. So this is going to be a mixture. But now the question is it going to be a heterogeneous mixture or a homogeneous mixture? So heterogeneous mixture could be something like, let's say, salt and water. And then your homogeneous mixture can be something like, sorry, I apologize, I switched those two. So your homogeneous mixture is something like salt and water, because salt dissolves very quickly and very well in water. So everything looks the same. We don't see any separate layers. We don't see any particles. Everything is well dissolved. The particles are evenly distributed. But if you look at a mixture of, let's say, what do I want to say? Let's say soil and water, or sand and water. So they are going to be insoluble. So you will see some sand particles, soil particles either at the bottom of the water. So that will be a heterogeneous mixture, because if you want to separate them, you can get the sand on the filter paper, and then the water should be able to go through the filter paper. In case of a homogeneous mixture, nothing is going to stay on the filter paper because everything is dissolved in the solution. Then we have which sample of matter is a mixture. So this thing is something that should be answered in like 5 seconds. All you have to remember is that solids, liquids, and gases, if they are in their pure form, they are not a mixture. Or at least we have not talked about in this class about the solid, liquid, or gas mixtures. So whenever you see an aqueous solution in your answer, that is your answer if the question is asking for a mixture, because aqueous solution means you have something dissolved in water. So in this case, we have magnesium chloride that is dissolved in water. For number 9, which statement describes the components of a mixture? So our options are: each component gains new properties, each component loses its original properties, the proportions of the components can vary, the proportion of the components cannot vary. So we already talked about the proportions, and we said that in case of mixtures, the proportions can change. The reason why 1 and 2 is not your answer is because when you are mixing 2 things, let's say you are mixing sand and salt, they are not gaining any new properties. They are just making a solution. And when we separate those 2 things, when we separate the sand and the salt, they're still going to have their original properties. So they are not gaining new properties. They are not losing their original properties. And we can always change the proportion in which we are dissolving them. So your answer is C. Which sample of matter can be separated into 2 different substances by physical means? So once again, here, this is the question that is the opposite of what we were looking at the previous slide. Now we are looking for a mixture. So if you look at your options, once again, you have a gas, a solid, and a liquid, and then you have an aqueous mixture, which aqueous solution, which we know is a mixture. Next up, it says, state in terms of particle distribution why the solution is classified as a homogeneous mixture. Now, please make sure that if the question says in terms of something, you do not ignore that part. So when you are answering this question, we do know what a homogeneous mixture is. I'm sure you all know what a homogeneous mixture is. This is when both the solute and the solvent are dissolved completely. Although that answer is correct, but when you answer this, you will not say that a homogeneous mixture is the one where the solute and the solvent are completely mixed or completely dissolved. In fact, what you're going to say is that a homogeneous mixture is the one where the particles are evenly distributed, because that's what the question is asking. So if you do not mention the words that are mentioned in the question, even if your answer is hypothetically correct, you are still not going to get the points, because that just means you didn't read the question correctly. So moving on to some more questions on matter and changes. So number 12 is saying which process can be used to separate a mixture of two liquids having different boiling points. So this will be your distillation, and the apparatus for the distillation is actually shown over here. So remember, this is if you we use distillation whenever you have two liquids that are completely dissolved. So for a homogeneous mixture of two liquids, and then we put them in this first flask and we start boiling them. Because they both have different boiling points, one of them is going to boil first, and when it boils, it's going to be collected in this beaker. So once we go past the boiling point of that first liquid, because we are recording the temperature using this thermometer, so once we go past the boiling point of that liquid, we know that we have most likely at least 95%, if not 100%, we have collected most of the first substance. So that's when we remove this beaker and we stop distillation, because whatever we have left in our initial beaker now is going to be the other substance or the other liquid. So this apparatus is for distillation. Then we have table sugar can be separated from a mixture of table sugar and sand at STP by adding what? So in this mixture, we have sugar and sand. So the first thing that we would want to do, because if we just take both of these things in the solid form, we cannot use filtration for this, because technically both of them are just solids. They are both going to stay on the filter paper, and there is no technique that we have learned to separate two solids from each other. So what we're going to have to do is dissolve this mixture of sugar and sand into water, because now what's going to happen is that the sugar is going to dissolve, the sand will not. So once we have that sugary solution, sugar water solution, and the sand, we can now go ahead and use filtration. Filtration is going to get the sand on top of the filter paper, and then we are going to evaporate the water from the rest to get the sugar. So this procedure will be option C, adding the water first, stirring to make the mixture, and then filtering out the sand. Although there will be a fourth step, which will be evaporation, but because that is not one of the options, so it's fine. We'll just ignore it. For the next question, explain in terms of particle size why the rock particles are trapped by the filter paper. Remember, filtration depends on the particle size. This is also a very common question. It just didn't show up on the exams. It hasn't shown up specifically on the exams that I looked at, but just make sure that it can show up. You should remember that filtration depends on the particle size, because the things that are bigger or that have a bigger particle size than the pores in the filter paper, they are going to stay on top of the filter paper. So when you answer this question, you're just going to say the particle size of the rock particles is bigger than the pores of the filter. That's your answer. So once again, if you don't mention particle size, your answer will be incorrect. So here are some more questions. Number 16 is asking for a physical change. So remember, physical change is something where the substance is not changing its chemical composition. So we are looking for the same chemical composition on both sides. So some examples of physical changes are phase changes. So in this case, if you look at all of the reactions, you can kind of see that except the first option, pretty much in all of the rest of the equations, the chemical composition is changing. So either the things are combining, or they are breaking down, or just converting into something different. So your answer will be A in this case, because all that's happening here is we are going from the solid phase to the gas phase, which is a phase change. For number 17, which statement describes a chemical property of copper? So chemical property is once again a property that if changed will change the chemical composition of that substance. Meaning, if we change this property, then that substance is not going to be copper anymore. So if you look at option A, that says it can be flattened into sheets. It's just a different shape, but it's still copper. Then copper has a red-orange color. Again, color is normally classified as a physical property, unless we react that substance with something and then we notice a color change. Copper conducts an electric current. Conductivity is normally also a physical property. And then lastly, we have option D, which says copper reacts with oxygen. So here we are talking about a reaction, because of course when we react copper with oxygen, it's going to become copper oxide, which is not going to be copper anymore. So your answer will be D. For number 18, at STP, a 50-gram sample of water that's in the liquid phase and a 100-gram sample of water that's in the liquid phase as well have. First option is different temperatures. They already told us in the question that they're both at STP, so this is not your answer. They have the same temperature. The same volume. The question doesn't give us any information about the volume, so we can just cross that out. They have different empirical formulas. So empirical formula is, remember, the least possible ratio of the formula. So the least possible ratio in this case is still going to be H2O. So that is also the same because it's still water. So that's not your answer. And then they have the same chemical properties. So remember, as long as it's water, the mass doesn't matter. You can take 50 grams or 100 grams. They are still going to have same chemical properties. Which process represents a chemical change? So once again, we are looking at a change that is going to change the chemical composition. So number one, a candle burns in air. When you burn the candle, it's not a candle anymore. So this one does change the chemical composition. So that is a chemical change. Iodine sublimes. Sublimation is a phase change. So it's just going from one phase to the other, still iodine. Water evaporates. That is also a phase change, still water. An ice cube melts, still a phase change. It's still going to be the same substance. Which process is a chemical change? Once again, we are not looking, we can go ahead and cross out any options that are phase changes. So sublimation, evaporation, condensation, they are all phase changes, so they cannot be a chemical change. They are physical changes. So it's going to be option D, which is synthesis of magnesium oxide, because we will have to react magnesium and oxygen to make magnesium oxide. Which property can be used to differentiate between a 50-gram sample of solid potassium nitrate at STP and a 50-gram sample of solid silver chloride at STP? So we are now looking at two different substances. So your options are the phase. The question told you they are both solids, so this is not a good answer. Temperature. The question told us that they are both at STP, so this is not a good option. Mass, the question told us we have 50 grams of both, so that is not a good answer. So the last option that we are left with is solubility. So solubility is specific to the type of substance. So some substances are dissolve very well in water, others don't. So let's go ahead and look at a few more questions. So we also see some particle diagrams here. So for number 22, compared to the chemical and physical properties of the compound CO, the compound CO2 has, now as you can see, they are two different compounds, and whenever we have two different type of substances, they are always going to have different properties. I can kind of guarantee that this question or something similar to this is going to show up on your exam. So please make sure that you remember that whenever we have two different substances, they always have different properties, both chemical and physical. So your answer in this case is going to be different chemical properties and different physical properties. Then for number 23, we see a particle diagram. And it says, which two particle diagrams represent two different phases of the same compound? When it says same compound, that means we are looking for the particles that are arranged similar way. So as you can see here, according to the key, one atom is represented by the empty circle, and the other one is represented by the filled circle. So if you look at your option, there are some different types that we see. Whenever you see the same type of atoms together, this is classified as an element, just a diatomic element, because you have two atoms. When you see two different atoms combined together, that one is a compound. So what you see in the first particle diagram is that you have some elements and some compounds. So this one overall is a mixture of an element and a compound. In the second one, we see a compound and the same compound everywhere else in the diagram. So this one will be classified as a compound. In number C, once again, we see compound and element. So this is also a mixture. And then option D is going to be a compound as well, because once again, it's on the same diagram that we see everywhere. So we're talking about different phases. So remember, in case of solids, the particles are very closely packed. Liquids, they are slightly separate, so they have a little bit more space. Gases, they have a lot more space, so they are very far from each other. So we are looking at two compounds. So this is a compound and this is a compound, and we clearly see that they are two different phases, because in diagram D, the particles are close to each other, so that is most likely a solid. And then in case of B, that represents a liquid or a gas. So your answer is B and D, which is option D. Then for number 3, once again, we have diamond and graphite, two different things, although they are two different forms of solid carbon, but still, if they are named differently, that means they are different things. So they are going to have different properties and different structures. Then for number 5, we are looking for something that represents a noble gas. One very quick thing to remember about noble gases is that they are always monoatomic. So that means this thing, although it has the same element everywhere and there's like a significant difference between the particles, so you can kind of say that this is also a gas, but this is not monoatomic, because this is not monoatomic, so it's not a noble gas. So your answer is option A. The rest of them, this one is a compound and this one is a compound. So that was it for the first topic. Let's look at the next one, which is about measurements. So here are a few questions. The first one is asking for the numerical setup to calculate the percent error for the percent composition by mass of water in the hydrated copper sulfate sample that was determined by student 2. So student 2 said that the mass of water in the hydrated copper sulfate was 1.11. And if you read the text at the top, they are saying that the accepted value for the percent of water in the hydrated copper sulfate is 36.1. Actually, apologies. They are not asking for the mass only. They are asking for the percent composition by mass. So this as you can see in this text, student to determine the percent composition by mass of water in the hydrated copper sulfate to be 37, and the actual value is 36.1. So you just have to remember the equation for percent composition by mass, which is measured minus accepted over accepted times 100. So that is going to be 37 minus 36.1 over 36.1 times 100. So the biggest mistake that people make with percent error questions is that they put the measured value at the bottom instead of the accepted. And if you do that, you're not going to get the correct answer, and so you lose the point. So please don't make that mistake, especially because you're given this equation in table T. So there is absolutely no reason for you to get this wrong. So please don't do that. Then for number 2, we have to state the number of significant figures in the mass of hydrated copper sulfate sample that was used by student 1. So student 1 said that the mass of hydrated copper sulfate is 3 grams, 3.00 grams. So remember, because these two zeros, although they are at the end, but they are after the decimal, so whenever there's a decimal in the number, the zeros that are after the non-zero digits, we do count them. So the total number of sig figs in this case are 3. So remember that very quick rule that we talked about in class, which is the Atlantic Pacific Ocean. If you do have a decimal present, so if you look at this question 3.00, if you do have a decimal present, we start counting from the Pacific side. Once we hit the first non-zero digit, we count everything after that. So this is going to be 3 sig figs. And if you don't have the decimal present, so if the decimal is absent, then we start counting from the Atlantic side, and we do not start counting until we hit the first non-zero digit. So that will be only 1 sig fig if there's no decimal here. And if it's only 3, then once again, decimal absent, start from the Atlantic side, and that will be 1 sig fig. If you have something like 0.300, now you also see a 0 before, so the decimal is present. We start counting from the Pacific side. Don't count the first 0 because we do not start counting until we hit the first non-zero digit. So that will be 3 sig figs. Right, moving on, here are a few more questions. So for density problems, just a very quick review. The equation for density, which is density is equal to mass over volume, this is given to you in table T. The equations that are not given to you, but you must remember, are the equations for mass and volume. So sometimes you might be given the density, or you might be asked to find the density from table S and solve for the mass. So in that case, you can simply do the crisscross. And if you want to solve for mass, mass is equal to density times volume. So this is the first equation that you must remember. And then the second equation that you should remember is the equation for volume. So now if I start with this mass equation, so mass is equal to density times volume, and let's say I want to have volume on this side, so I can go ahead and divide both sides by density. So it gets cancelled here. The equation for volume is mass over density. So these are the two equations that you do need to memorize because they are not given in table T. The only one that's given in table T is for density. So in question number 3, it's asking compare the density of helium in the cylinder when the volume is 50 milliliter to the density of helium in the cylinder when the volume is decreased to 25 milliliters. So there are a few ways in which you can answer this question. You can either just go ahead and do the math simply, so plug in all of the numbers in the equation. You are not given the mass in this question, so you can just have like a hypothetical mass. So maybe have like 1 over 50 for the first one, and 1 over 25 for the second one. So the first one is going to be the first one gives you about 0.02, and the second one gives you about 0.04. So you can just say that the density of the density will be higher when the volume is 25 milliliters, if the mass is the same, because they didn't say that we are changing the mass. For number 4, now it's saying if you have a 26.7 gram sample of which element has a volume of 3 cubic centimeters at room temperature. So this is an interesting question because you're not just calculating the density. In fact, you're using the density to find the identity of the element. So this is simply your mass over volume. So when you do 26.7 divided by 3, that gives you about 8.9. So you're looking for something that has the density of 8.9 grams per milliliter. So go ahead and go to your table S and figure out which element will that be. So moving on to the next unit, which is atomic concepts. And this is, I'm pretty confident in saying that this is a very popular unit on the Regents exam. So you can expect to see somewhere around like 7 to 8 questions from this unit. So please make sure that you are well familiar with all the concepts. So here are the first few questions. So these questions are kind of about the atomic theories. So please make sure that you are familiar with the atomic theories, especially the Rutherford theory, the wave mechanical. So you should know what the orbital means. You should know who discovered the electrons, and then you should know what Bohr said. Dalton is not that common, but the rest of them are something that you should be familiar with. So the first question is saying what conclusion was proposed as a result of an experiment during which some alpha particles were deflected while passing through a thin sheet of gold foil. So this was Rutherford's experiment, and if we remember, Rutherford bombarded the alpha particles on a thin sheet of gold foil. Some of them went straight, some of them deflected in different directions, and some of them bounced back. So Rutherford said that the reason why some of them were going in different directions or bouncing back is because there was something positively charged in the middle of the atom that was repelling those particles, which is why they were coming back. So Rutherford was the one that discovered that positively charged nucleus, and then Rutherford also said that in general, because a lot of the particles were able to go pass straight through, that was because there's a lot of empty space between in the atom, which is why there was nothing that the particles were interacting with. So it was just empty space. The particles were able to go straight through, and Rutherford was able to record them on the other side of the sheet. So the conclusion here was that atoms have small, dense positive nucleus. That was one part of Rutherford's experiment and his conclusion. And the second part was that atom is mostly empty space. So remember the ESPN. This was Rutherford's conclusion. So that means atom is mostly empty space and has a positive nucleus. Then for number 2, we are talking about the wave mechanical model. So in the ground state, the 10 electrons of a neon atom would be located. You should know that wave mechanical model was the one that said that electrons are actually in the orbitals, which are spaces where we have a very high probability of finding an electron. But electrons are not specifically in like specific circular orbits that were mentioned by Bohr. For number 3, which proposal is in the development of the modern model of the atom was made before the others? So we are talking about the one that was discovered we are talking about the one that was proposed at the very beginning. So the first option is atoms are hard indivisible spheres of the different sizes. Atoms are mostly empty space. We just said that this one was Rutherford, so that was not the first one. Atoms have electrons that have wave-like properties. This one was the cathode ray tube experiment by Thomson, so that was also not the first one. And then atoms have an internal structure that contains negative particles, which is kind of like what Thomson said somewhat, so also not our answer. So the first one was this, which was presented by John Dalton. Then for number 4, which subatomic particles were discovered as a result of experiments with cathode ray tubes. So this experiment was done by J.J. Thomson, and after the cathode ray tubes, the subatomic particles that was discovered was the electrons. Here are a few more questions. For number 5, which particles surround the nucleus of a neon atom? So remember, outside the nucleus, we always have the electrons, whether it's not just specific to a neon atom, for all the atoms. For number 6, which subatomic particles are matched with their charges? So we have protons that are positively charged, we have electrons that are negatively charged, and we have neutrons that have no charge. So positive nucleus, negative electron, neutron with no charge. So the correct answer that we see here is number 2. Then we have number 7, which says what is the overall charge on the nucleus of a fluorine atom? So you just have to figure out how many positive charges do we have in the nucleus of a fluorine atom. So remember, the charge on the nucleus is always positive because inside the nucleus we have a proton and a neutron. protons are positive, neutrons have no charge. So the charge of the nucleus depends on the number of protons only. So figure out how many protons you have in fluorine, which I believe is 9. So that will be positive 9. What is the net charge of a monoatomic ion that has 15 protons, 16 neutrons, and 18 electrons? Now remember, when we are talking about the net charge, that means we are talking about the charge on the atom. And that depends on the number of protons and the number of electrons. Number of neutrons do not matter because they have a charge of 0. So in this case, what we are saying is that we have 15 positive charges and we have 18 negative charges. So overall, as you can see, we have more negative charge. So you just have to calculate that difference. So because it's 3 more negative charges, so the overall charge is going to be -3. The mass of each proton and each neutron is approximately equal to. This is a very important concept to remember. When we are saying approximately equal to, we are only talking about the relative number. So if we are saying that the mass of a proton is about 1 atomic mass unit, which is this symbol, this means atomic mass unit, then the mass of a neutron is also about 1 atomic mass unit. What we are trying to say here is that the proton and the neutron pretty much weigh the same. The electrons are significantly lighter to a point where their mass is negligible. But remember, we do not want to say that electrons have a mass of 0 because they do exist. If something has a mass of 0, that means the thing doesn't exist. So protons and neutrons weigh the same. Electrons are significantly lighter, which is why for atomic mass, we only count the mass of the proton and the neutron. So what is the approximate mass of an atom that has 10 electrons, 10 protons, and 9 neutrons? So remember, we do not need to consider the mass of the electrons. So we can only consider the mass of the protons and the neutrons. So that will be approximately 19. Here are a few more questions from Atomic Concepts. For number 11, all atoms of an element have the same atomic number or number of protons. So number of protons determine the identity of that atom. This concept should be on your fingertips. What's the number of protons in an atom with the electron configuration 2, 5? So quick reminder on electron configuration, this means we have 2 electrons in orbit number 1 and 5 electrons in orbit number 2. So there are 2 orbits in this atom. So overall, we have 7 electrons. And for a neutral atom, an atom that has a charge of 0, the number of electrons is equal to, number of electrons is equal to the number of protons. Once again, this only applies to a neutral atom, the one that does not have a charge. And I spelled neutral wrong. Right, neutral. Right, amazing. So that means if you have 7 electrons, we should have 7 protons. So in a ground state, valence electrons of a krypton atom are found in. So your valence electrons are defined as the electrons in the outermost shell. So this is just a definition problem. Which atom has a mass of 12 atomic mass units? So we are looking for something where when we add the number of protons and neutrons, we get 12. So for A, when you add protons and neutrons, you get 8. For E, when you add protons and neutrons, you get 12. For G, when you add 6 and 7, you get about 13. And then for J, you get about 24. So your answer to this question will be E. Because once again, remember, mass is the number of protons plus the number of neutrons. For number 15, in all atoms of bismuth, the number of electrons must equal the number of protons, as we just said. And because this is saying an atom of bismuth, we are just going to assume that this is a neutral atom. Because if it had a charge, the question would have said in all ions of bismuth. So if it says atoms, we can assume, safe to assume that this is a neutral atom. What's the net charge of a monoatomic ion? Now here we're talking about an ion that has 15 protons, 16 neutrons, and 18 electrons. This question is similar to the one that we did before. I think it's the same question. So that should be 3 minus because we have 3 more electrons. Then we have number 17, which particle remains undeflected when passing through this electric field. So remember, in chemistry, opposite charges attract. So the things that are negatively charged are going to be attracted towards the positive side. The things that are positively charged are going to be attracted to the negative side. So the only thing that is going to be able to pass straight through is the one that has no charge. So that will be your neutron. Then we have some short response questions. So explain in terms of subatomic particles why atoms of hydrogen 1, hydrogen 2, hydrogen 3 are each electrically neutral. When we are saying something is, or an atom is electrically neutral, that means the number of protons is equal to the number of neutrons. Now, someone might say, but how do we know, sorry, apologies, not neutrons, electrons. Neutrons do not impact the charge. So someone might say that, well, how do we know that the number of protons are equal in all 3 of them when we see a different number written next to hydrogen? Because remember that this number that is written with the symbol of the element is the mass number. And mass number is the number of protons plus the number of neutrons. Mass number has nothing to do with electrons. And when we see the same element written with 3 different numbers, we know for sure that the number of protons is not changing in all of them. And we know that because it's still the same element. So as long as it's the same element, it's going to have same number of protons. So the only thing that's changing here is the number of neutrons. So if the number of protons is the same, that means number of electrons is also going to be the same. So to answer this question, you can simply say this part. So you can say these 3 atoms are electrically neutral because the number of protons is equal to the number of electrons. So state the number of valence electrons in an atom of sulfur 32 in the ground state. Just look at the electron configuration of sulfur. Look at how many electrons you have in the outermost shell. That's your answer. Determine the number of neutrons in an atom of Am241. So this is going to be calculating the number of neutrons, which I hope we all still remember is going to be the mass number minus the atomic number. So the reason why we are doing that is because remember, our mass number is protons and neutrons. So when we go ahead and subtract the number of protons from that, we are left with the number of neutrons only. Then 21 is state the number of electrons in an atom of lithium-7. So go to lithium, its electron configuration. You can add the number of electrons, or you can simply look at the number of protons for lithium, the atomic number, and that will be your answer. And then state in terms of neutrons why a water molecule containing oxygen 18 atom has a greater mass than a water molecule containing oxygen 16 atoms. So the question says in terms of neutrons. So to answer this question, you can just say oxygen 18 has more neutrons. So once again, these are 2 different forms of oxygen. So they have same number of protons. So the only thing that's different will be the number of neutrons. Or you can also say the oxygen 18 has 2 more neutrons. That is also totally fine. All right, a few more questions. Which electron configuration represents the electrons of an atom in an excited state? So remember, excited state is a very temporary state. This is when you provide energy to an atom and the electrons get excited. So they move to a higher energy level because now they have more energy. But it's very temporary because very quickly the electrons come back to their original state, which is called the ground state. And as they are coming back, they release some energy that they had absorbed initially. So we are, to answer this question, we are looking for an option where we have an unfilled orbit, but we still have electrons in the next orbit. So if you look at option 1, you can see that orbit number 1 is complete. Orbit number 2 is incomplete because it can actually fit 8 electrons, but we only see 7 in this case. So what this tells us is that 1 electron from the second orbit has moved to the third orbit. So this could be an excited state. If you look at option 2, we see that orbit number 1 is complete, orbit number 2 is complete. So in this case, nothing is incomplete. So this is just the ground state. If you look at option 3, we have 2, 8, 8, 1. So 1 looks complete, 2 looks complete, 3 looks somewhat complete. So this is also a ground state. And then in case of 4, 2 is complete, 8 is complete, and we do have some ground states because orbit number 3 can essentially have 18 electrons, but after we fill in 8 electrons, 2 electrons go to the start filling orbit number 4, and then they come back to fill orbit number 3 completely, because that's how energies work. For you guys who have where we have not talked about the specific energies or how the orbits are filled, you can simply just look at the periodic table and see if there is an element that has this oxidation state written, because if there is an element with this ground state oxidation state, then this just represents a ground state. Same thing for the previous one. So your answer in this case will be 1. So compare the energy of an electron in the first shell of a lithium atom to the energy of an electron in the second shell of the atom. So one question that you should absolutely not get wrong. Remember that the energy of the orbits increase as we go away from the nucleus. So electrons need to have more energy to occupy the orbits that are farther from the nucleus. So you'll simply just say that the second shell has more energy than first. Then identify the noble gas that has atoms in the ground state with the same electron configuration as the nitrogen atom in a molecule of ammonia. Now this is interesting. If you remember, we said that ammonia is NH3. Now, if you draw this out, nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5. And these 3 electrons that are not in a pair, they are going to make a bond with hydrogen. So overall, if we have to count the electrons that nitrogen has, because it has 5 of its own, and then it's also sharing 3 electrons with hydrogen. So nitrogen actually has 8 electrons in this case. So we are looking for a noble gas that has 8 electrons. So go to the periodic table and find the noble gas that has 8 electrons. Then we have a few more questions. So which change in electron location in an atom of calcium is accompanied by the greatest amount of energy emitted? So when we are going from shell 1 to shell 2, because we are going from low energy to high energy in this case, the energy is actually going to be absorbed instead of being emitted. So this is not your answer. When we go from shell 2 to shell 1, now energy is going to be emitted. So this could be a possible option. Then as we go from 1 to 4, in this case, once again, we are going from low to high. So energy is going to be absorbed instead of emitted. But when we go from 4 to 1, this could be a possible answer. So, but the question is asking for the greatest amount that is emitted. So remember, if we are coming back from 4, which has significantly more energy compared to 2, so when we come back from 4 to 1, that is going to release more energy compared to when we are coming back from 2 to 1. So as an atom in the ground state changes to an atom in an excited state, so remember what we are saying here is that when it's in the ground state, it's in a low energy state, and then it's going to a high energy state. It needs to absorb the energy to be able to go to that high energy state. And then here we have 2 atoms. The question is saying what is represented by diagram 2. So what we see here is that electron was in orbit number 1, and then it moved to orbit number 3. So it looks like the electron got excited and it moved to a higher energy level. So we can say this, that an atom of hydrogen is in an excited state. We know for sure this is hydrogen, although this will be written in the question somewhere, but because in this case we don't see the entire question, so we know this is hydrogen because it only has one electron, and hydrogen only has one electron. And then this, I believe, these are the last questions. So which elements are present in the mixture? This is about bright line spectrum, and there are only 2 things that you need to know about bright line spectrum. The first is that you will be given a spectrum of different elements, and then you'll have a mixture, and your job will be to identify what elements do we have in the mixture. So all you have to do is match the lines. So if I look at the mixture now, I see that the first line comes from element E. The second line seems to come from element E as well, and there is also a line in J. The third line and the fourth line, that double line, is in element G. Then I see this line, which seems to come maybe from L, but also from E. And then I see the last one, which seems to come from E. So remember that although I see one line from element J and one line from element L, probably in our mixture, we will not say that we have J and L in our mixture, because all of the lines must be present in the spectrum of the mixture. So element E has all of its lines present, which is why we are sure that element E is present in the mixture. Element G also has all of the lines in the mixture, so we are certain that G is present. So your answer is E and G. And then the second type of question that you must be able to answer is, how is the bright line spectrum created? So remember how we were saying that when an electron absorbs energy, it goes to a higher energy level, and then when it's coming back and it releases that energy is what creates the bright line spectrum. So you can say that when you are answering this question, remember that the absorbing part is not creating the spectrum. So even if you are answering this question as a short response, make sure that you do not include this part. The absorbing has nothing to do with the creation of the spectrum. The only thing that you need to mention is that the electron comes back from an excited state to a ground state, or you can also say from a higher energy state to a lower energy state, and releases energy. So the correct option here will be D. It releases energy and moves to a lower energy state. And that was it for your, actually no, sorry, never mind. A few more questions. These are the last ones. So state in terms of both protons and neutrons, while UUS-293 and UUS-294 are isotopes of the same element. So we know they are the same element because they have same number of protons. So for your answer, you'll say they have same number of protons, and we know that they are different isotopes because they have a different mass, which means they have different number of neutrons. So for your answer, you'll just say these atoms have same number of protons, different number of neutrons. And then this is something that you must know how to do. And that is calculating the atomic mass, or average atomic mass. So this is not your regular average. This is actually the weighted average of the masses of all of the isotopes. So we take into account the mass and the percent abundance of all of the isotopes. So you have a few ways to answer this question. First way is, what is our correct answer in this case, which is option 4. So as you can see, what they did is that for copper 63, we multiplied the mass of copper with the with this percent, but after dividing the percentage by 100. So if we divide this by 100, we get 0.6915. If we divide this by 100, we get 0.3085. So we multiply these two, add them. So that is your average atomic mass. The second thing that you can do is, if you are writing it like this, the reason why 1 is incorrect is because if you're just writing your, sorry, not 1, 2. The reason why 2 is incorrect is because if you just go ahead and write your mass with the percentage, when you multiply them and add them, you end up with a huge number, which is very different from the atomic masses of the isotopes. So you must remember to divide your answer by 100 to make sure that you are accounting for that percent unit. And a third variation of this answer that had showed up very rarely, but sometimes on the Regents exam, is that they write it in this form, but instead of dividing it by 100, they just go ahead and write a percentage with the percent. So if you don't see either your answer dividing by 100 or you don't see your percentages multiplying after they have already divided by 100, then look for something like this where the percentage is written, because the percent sign technically indicates that we still need to get rid of this percentage before we get to the final answer. And then for number 33, which notations represent atoms that have the same number of protons but a different number of neutrons? So we are looking at some isotopes. So remember, isotopes represent the elements of the same element, the atoms of the same element, because they have same number of protons. So if you see different elements like hydrogen and helium, those are not isotopes. See sulfur and sulfur, although it's the same element but the mass is also the same, that means they are not isotopes. If you see chlorine and chlorine, same element, and they have different number of neutrons, so these could be isotopes. Then here you have Ge and Ge, they're like different elements, so not your answer. And then lastly, based on the atomic number of element nitrogen on the periodic table, compare the relative abundances of the naturally occurring isotopes of nitrogen. This is kind of a rare question, but you must know how to answer this. So if you look at your periodic table, let me pull up my periodic table very, very quickly. Okay, so if you look at your periodic table and you go ahead and look at the mass of nitrogen, we have about 14.00 something, so that can be rounded to a 14. So because that number is closer to the mass of 14, we can say that this isotope is more abundant. So to answer this question, you'll say that nitrogen 14 is more abundant because the atomic mass on the periodic table is closer to 14. So that was it for the atomic concepts. Moving on to the periodic table. So here are a few questions. First things first, you must remember that the elements on the periodic table are arranged in order of increasing atomic number and not the mass number. The very first periodic table ever was arranged based on the mass number, so the one by Mendeleev. An element that is very reactive metal could have an atomic number of. So remember, we said that elements in group 1 and group 2 are very reactive, so you are looking for something that is either in group 1 or group 2. So that could be something with an atomic number of, actually no, something with an atomic number of 2 is helium, which is not in group 1 or group 2, and it is not a metal. So this is actually helium, and the element with the atomic number of 9 is fluorine, which is also a non-metal. Element with the atomic number of 19 is potassium. An element with the atomic number of 79 is silver, which is not in group 1 or 2. So your answer is 3 because potassium is in group 1. And group 1 has the most reactive metals. For number 3, we have at 298 Kelvin and 1 atmosphere, which noble gas has the lowest density? So the densities that are given to you in table S, they are actually at these conditions. So you can just go to table S, find the densities of each one of them and see which one has the lowest density. For number 4, which element is a non-metal and solid at STP? So first of all, let's identify your non-metal. So lead is a metal, not your answer. Nitrogen is a non-metal. Then sodium is a metal, so that is not your answer. And sulfur is a non-metal. So out of nitrogen and sulfur, we actually do already know that nitrogen is a gas, so that is not going to be your answer. So in this case, this is sulfur. So a very quick reminder, you have that staircase on your reference table packet. All of the elements that are on the right of the staircase are nonmetals. All the elements that are on the left are metals. The elements that are closer to the staircase are your metalloids. But except aluminum and polonium, these two are metals. So for number 5, which element has chemical properties that are most similar to potassium? This is a question that shows up a lot. The basic thing that you need to remember is that if elements are in the same group, they are going to have similar properties. So we are looking for something that is in the same group as potassium. So calcium is not in the same group, it's in group 2. Potassium is in group 1. Cesium is also not in group 1, or is it? Sorry, it is. Cesium is in group 1. Nitrogen is in group 15, and your sulfur is actually in group 16. So the answer here will be cesium. So which information is sufficient to differentiate a sample of sodium from a sample of silver? So both of them are metals. So let's look at some options. The mass of each sample. The thing is, the mass kind of has no impact on the properties. Same thing with the volume. So those are not good options. The reactivity of each sample, that could be a good one because sodium is in group 1, so that is going to be significantly more reactive than silver. The phase of each sample, that's a physical property, and again, we can always change the phases, so that also does not impact their identity. So which list of elements includes a metal, a metalloid, and a noble gas? Whenever you see a question like that, make sure your option is in the same order that's given in the question. So that's it. That's all that you're looking for. So if I look at my options, I see strontium, silicon, and radon. Although, so strontium, silicon, and radon. So this looks like the best option. The rest of them have a different order. All right, moving on to a few more questions. So which element is malleable at STP? Make sure that you know the properties of metals, nonmetals, and metalloids. So malleability is a property of metals, so we are looking for a metal in our answer. So chlorine, we know, is a non-metal. Copper is a metal. Helium is a non-metal, and sulfur is also a non-metal, so your answer in this case will be copper. Element in group 14, period 3, is classified as, so if I look at group 14 and period 3, I have silicon, which is next to the staircase, so it's a metalloid. Explain in terms of electron configuration why sulfur atoms and oxygen atoms form compounds with similar chemical properties. So in this case, it says in terms of electron configuration. So you are not going to say, to answer this question, that they're in the same group. In fact, you are going to say that they have same number of valence electrons. Because if elements have same number of valence electrons, they have a lot of properties that are very similar. But if the question would have said explain in terms of the periodic table, or explain in terms of the group or the period why sulfur and oxygen have similar properties, then you would have said because they are in the same group. For number 11, compare the electrical conductivity of an alkali metal with the electrical conductivity of a halogen. So we do know from our prior knowledge that metals have a higher conductivity, and that is because metals have the sea of electrons, the free-flowing electrons between the cations that allow for the conduction of electricity. So don't forget the sea of electrons in metals. Explained in terms of electrons why the halogens are all placed in the same group on the periodic table. So once again, this does not say in terms of properties. If it would have said in terms of properties, the answer would have been because they have similar properties. But now it says in terms of electrons, so you can just say because they all have 7 valence electrons. So the key here is to pay attention to the question. Identify the 3 endangered elements listed in the passage that are classified as metals. So the elements that we see here are helium, which we know is a non-metal. We have zinc, which is a metal. Gallium is a metal. Then we have indium, which is a metal, and we have tellurium, which is also a metal. So you can say any of those 4 as metals. Here are a few more questions. So which term is used to describe the attraction that an oxygen atom has for the electrons in a chemical bond? So that is the definition of electronegativity, how strongly an atom can attract the electrons. So an atom of which element has the strongest attraction for electrons? So you see how here they did not word or name the specific property, they just gave you the definition. So strongest attraction for electrons, meaning we are looking for something that has very high electronegativity. So a few ways to answer this question is 1, remember the trends. So we know that as we go down the group, because the atomic mass increases, atoms become bigger. That means their tendency to attract other electrons decreases. So down the group, electronegativity is lower. Across the period, electronegativity is higher because now atoms are getting smaller, so there are more chances that the nucleus can attract electrons from off other atoms too. So down the group decreases, and across the period increases. The problem, however, is that these trends only work if the 4 options that you are given are either in the same group or in the same period. So if you don't have your 4 options that are in the same group or the same period, then you do the shortcut, which is you go to, or maybe not so much of a shortcut, but you do option 2, which is you go to your table S and you look at the values for electronegativity for each one of them and see which one is the highest. So use either of those 2 options to answer this one. Then for number 16, as the first 5 elements in group 14 are considered in order from top to bottom, there are changes in both the number of valence shell electrons. We know valence shell electrons are not going to change because they are in the same group. So this is not your answer. And 3 is not your answer because that also says the same thing. The electronegativity values, yes, we know they are going to change. And the number of first shell electrons, interesting. Remember, the first shell can always hold 2 electrons. So this is also not our answer. So the correct answer is electronegativity and atomic radii. Then as the elements in period 2 are considered in order from lithium to fluorine, there is an increase in the... So we are now looking at the period and we are saying which thing is going to increase. The atomic radius. So as we go across the period from lithium to fluorine, we do add an extra electron every time and an extra proton. However, the number of orbits are the same. So because the nucleus is becoming stronger and stronger, the atomic radius actually decreases instead of increasing. So that's not your answer. Because atomic radius decreases, that means it becomes easier for the nucleus to attract other electrons. So electronegativity goes up. The number of electron shells are going to stay the same because they're in the same period. And number of electrons in the first shell are also going to stay the same because they are always 2. For number 18, as the elements in period 2 of the periodic table are considered in order from left to right, which property generally decreases. Now we are looking at something that decreases. So if it's the period, atomic radius is going to decrease, as we said earlier. So that is your answer. Electronegativity increases, as we mentioned. It becomes easier to attract electrons. Ionization energy increases. It takes more energy to lose an electron because there's a lot of nuclear attraction. And nuclear charge also increases because we have more protons. So compared to metals in period 2, the nonmetals in period 2 have. So metals in general want to lose electrons, which means they have low ionization energies. It's very easy for them to lose electrons, and they have they have low electronegativities, meaning they have very little attraction for electrons on other elements. So if we look here, nonmetals generally have higher ionization energy, so 1 and 2 is not your answer, and higher electronegativities. So your answer will be 4. Here are a few more questions. So identify the element in period 3 that requires the least amount of energy to remove the most loosely held electrons from a mole of gaseous atoms of the element in the ground state. So the question is saying requires least amount of energy to remove an electron. So we are talking about something that has a lower ionization energy in period 3. So remember, when we go across the period, we go from metals to non-metals. So if we are looking for low ionization energy, we should be looking for a metal. So you can identify any metal in period 3 as your answer. Explain in terms of atomic structure why the radius of a cesium ion in cesium chloride is smaller than the radius of a cesium atom when both are in the ground state. So cesium actually has an electron configuration of 2, 8, 18, 18, 8, 1. When cesium becomes an ion, cesium is going to lose this electron. Now remember, when an atom loses an electron, it also loses the outermost shell in which that electron was living in. So the answer to this question is that cesium loses the valence electron and the valence orbit. So if you do not mention that cesium is losing its valence orbit, you will not be answering this part in terms of atomic structure, and so your answer will be incorrect. You cannot just say cesium is losing an electron. You have to say that it's also losing an orbit. Then 22 says compare the radius of chlorine atom to the radius of chloride ion. So chlorine has an electron configuration of 2, 8, 7. So because 7 is closer to 8, so chlorine is actually going to gain an electron to become an ion. So when chlorine gains an electron, what happens is that the nucleus still has the same amount of protons. We are not adding anything to the nucleus, but now nucleus has to take care of more electrons, which decreases the nuclear attraction. So what's going to happen is that the ion is going to end up having more radius than the atom. And the reason for that is because there's less nuclear attraction. So when the question is only saying to compare, you can simply say chlorine ion has more radius than chlorine atom. That's it. You don't really have to explain if the question is not asking you to explain. For 23, state the general trend in atomic radius as the elements in period 3 are considered in order of increasing atomic number. So we have mentioned this already, that across the period, the atomic radius decreases because there's more nuclear attraction, and the question is only asking to state, so you do not have to explain. Explain in terms of electron shells why the atomic radius of an atom of indium is greater than the atomic radius of an atom of gallium when both atoms are in the ground state. So the The reason why, because it is in terms of electron shell, so you can simply just say indium has a bigger radius because indium has more electron shells. So if you look at the periodic table, gallium is actually in period 4 and indium is in period 5. So indium has 5 orbits. And that will be your answer. State the trend at standard pressure of the boiling points of these noble gases as they are considered in order of increasing atomic number. So to answer this question, you can simply look at the boiling points of the noble gases in table S. So look at table S. In general, as the atomic number increases and the substances become bigger, the boiling point also increases. But make sure you verify that using table S. So write down the number somewhere and you'll just say as the atomic number increases, the boiling points increase. And that will be your answer. So that was it for the periodic table unit. Now let's talk about some chemical bonding. We've got some questions here. So which terms identify the two different major categories of compounds? So we have ionic and covalent compounds, and remember, another name for covalent is molecular. So your answer here will be ionic and molecular. So once again, because molecular is covalent. Which element has a metallic bond at room temperature? So only metals have metallic bonds. So in your answer, you're looking for a metal, which is sulfur. A substance, not sulfur. Sulfur is a non-metal. That will be cesium. A substance conducts electricity in the liquid phase but not in the solid phase. This substance can be classified as, so this right here is the property of ionic compounds. So in the solid phase, the ionic compounds are compact. There is no movement of ions. When they're in the liquid phase or the aqueous phase, so let's also write AQ here, the ions are now moving, so they can conduct better electricity. Which Lewis dot diagram represents an atom of nitrogen in the ground state? Nitrogen has 5 valence electrons. So in Lewis dot diagram, we represent of the atoms. We only need to include the valence electrons. So this changes for the compounds. It's different for ionic and covalent. We'll talk about that in a bit. I think we'll have some questions. So this one will be 2 because nitrogen has 5 valence electrons. So krypton atom in the ground state tend not to bond with other atoms because they're so krypton is actually a noble gas. So it does have a complete octet. So let's say it says second electron shell contains 8 electrons. The second electron shell, yes, it does contain 8 electrons, but krypton actually has 4 shells, so the second one doesn't really matter. The third electron shell contains 18. Yes, it does, but that does not matter. Innermost electron shell contains 2. Once again, true, but doesn't matter. The only one that matters is the outermost electron shell, and that contains 8 electrons, meaning it has a complete octet, which is why it doesn't want to bond. So which compound has covalent bonds? Remember, covalent bonds are between nonmetals and nonmetals. So we are looking for 2 nonmetals bonding. So that looks like H2O because hydrogen and oxygen are both nonmetals. The rest of them have a metal and nonmetal, so they're all ionic. Which part of a calcium atom in the ground state is represented by the dots in its Lewis electron dot diagram? So as we just mentioned, that is going to be the electrons in the outermost shell. And for calcium, which is in group 4, the outermost shell is, not group 4, period 4. So the outermost shell is going to be shell number 4. So the electrons in the 4th shell are what we represent in the electron dot diagram or Lewis dot diagram. Right, a few more questions. So state the type of chemical bonds formed when an alkali metal and a halogen react to form a compound. So we have a metal and a halogen, which is a non-metal. So this is going to be ionic. Then state the type of chemical bonding in a sample of calcium oxide. So calcium is a metal, oxygen is a non-metal, so this one is also going to be ionic. Then identify the two types of chemical bonds in the product of this reaction. The reason why we have two different types of chemical bonds is because this right here is a polyatomic ion. So remember we said that in case of polyatomic ions, we normally have non-metals bonding, so they have covalent bonds. But then because they are ions, they have a charge. So ammonium ion has a positive charge, chlorine has a negative charge. So when they combine, that will be an ionic bond. So in this case, we have both ionic and covalent bonding. State in terms of element classification why carbon dioxide is a molecular compound. So you can say because they have two nonmetals bonding. So that will be in terms of element classification. Right, few more questions. When a fluorine atom becomes a fluoride ion, the fluorine atom, because it's gaining a negative charge, that means it has more electrons than it had as an atom. So that this is going to be gaining an electron. Which atom forms an ion when a radius is larger than the atomic radius? So the radius is larger than the atomic radius. The radius of an ion is larger than the atomic radius whenever we form a negative ion or an anion. So we are looking for something that is going to make an anion, which is normally nonmetals. So if you look for a nonmetal in your option, that is going to be oxygen. Which formula represents chromium 3 oxide? So when we are writing formulas, we write the two elements that we have and we write their charges. So for chromium, it's a transition metal, so it has multiple charges, but the question does give you the charge of chromium, which is +3, and oxygen has a charge of -2. There's only one charge in the periodic table. So to write the formula, we do the crisscross, bring the numbers down, so chromium gets a subscript of 2 and oxygen gets a subscript of 3. So your answer in this case is 3. Then what's the chemical formula of sodium oxalate? Now in this case, sodium we know is an element that has a charge of +1, but oxalate is not ending with IDE. When something doesn't end with IDE, that is a pretty good indication that this is most likely not just an electron. This could be a polyatomic ion. So you can go to table E to look at the formula for that polyatomic ion. So oxalate is actually Cr2O4 with a charge of -2. So when we do the crisscross in this case, sodium gets a subscript of 2, and then we have Cr2O4 that gets a subscript of 1, which we don't need to write. So the answer in this case is 4. Write the chemical name for the compound CuS. So if you are doing the opposite thing, meaning going from the compound to the name, then we can do the anti-crisscross. So now we can bring those numbers up that we initially brought down to make the subscript. So now copper seems to have a charge of +1, sulfur seems to have a charge of -1. Now before you go ahead and just jump right into name this, make sure that the charges that you have make sense. So you're going to look at chromium and see if +1 is a possible charge if it's given in the periodic table. Same thing with sulfur. So if I look at the periodic table, and if I look at copper, the copper can either have a charge of +1 or +2, so that is fine. But sulfur can only have a charge of -2. So that means this formula that was given to us was most likely the simplified form of the formula. So if I change the charge of sulfur to be -2, then that means copper must be +2. Because again, this was simplified, so the ratio should still be the same. So the correct name will then be copper with a charge of 2 sulfide. Because this is just an element, so we are sure it should end with IDE because sulfate is a polyatomic ion. What's the chemical name of the compound NH4SCN? Now, because you see more than 2 elements here, that means we might have some polyatomic ions. So NH4 is one polyatomic ion that has a charge of +1, and then SCN is the other polyatomic ion that has a charge of -1. So the name for NH4 and SCN, you can get them from table E once again. So NH4 positive is ammonium ion, and SCN is actually thiocyanate. So your name here is ammonium thiocyanate. Write a chemical name for NaNO3. So once again, we can go ahead and do the anti-crisscross, but first make sure that we don't have any polyatomic ion. So if sodium is the element, NO3 is actually going to be the polyatomic ion with a charge of -1. And so sodium only has one possible charge, which is +1. So when we name this, it's going to be sodium, and then name the NO3, which is nitrate. And then identify the element in period 3 that reacts with oxygen to form an ionic compound represented by X in the formula X2O. The way you can answer this question is by figuring out the charge of X. Because remember, elements in the same group in most cases have similar charge. So X comes before, that means X should be a metal. That is one thing we know. And then when we figure out the charge, and do that anti-crisscross thing, X get a charge of +1 and oxygen gets a charge of -2. So we are looking for a metal that has a charge of +1, which is most likely going to be in group 1. So your answer to this question could be any element that is in group 1. So you can either say sodium, potassium, anything along those lines. Right, here are a few more questions. For number 20, which molecule of an element contains a multiple covalent bond? So multiple covalent bond means more than one bond. So all of the halogens, if you see any halogen, they have 7 valence electrons. So bromine and fluorine, they have 7 valence electrons. So they only need one bond. So these are going to have one bond, one bond. Hydrogen only has 1 electron, so that is only going to make one bond by sharing that 1 electron. Oxygen has 6 valence electrons because it needs 2 more to have a complete octet. So oxygen is going to be the one that makes a double bond. So your answer here is oxygen. Which molecule is symmetrical in both shape and distribution of charge? So you can go ahead and draw this one out. So HCl is just hydrogen with 1 electron. Then we have chlorine with 1, 2, 3, 4, 5, 6, 7. And there's your bond. So that is pretty symmetrical. However, the charge on hydrogen is partial positive. The charge on chlorine is partial negative. So actually this is asymmetrical. Then we have H2O. We have oxygen here with 1, 2, 3, 4, 5, 6. And then we have 2 hydrogens. So oxygen is partial negative. Hydrogen is partial positive. When you draw your lines of symmetry, this is asymmetrical as well. So NH3, nitrogen has 1, 2, 3, 4, 5. So hydrogen, hydrogen, hydrogen. So nitrogen is partial negative. Hydrogens are partial positive. So once again, when you draw the lines of symmetry, this one turns out to be asymmetrical. So lastly, we have CH4. Carbon has 4 electrons. And we are going to have 4 hydrogens on each side. So when you now draw your lines of symmetry, this one seems to be symmetrical. So your answer to this question is going to be CH4. Then the Lewis dot diagram that represents H2S. This right here is how you draw the Lewis dot diagram of covalent substances. So sulfur has 6 valence electrons. The 2 single electrons are going to bond with the 2 hydrogens. So the problem with the first structure is that there's one side of sulfur that doesn't have any electrons, and we don't know where the electrons for hydrogens are. Problem with this one right here is that the electrons of hydrogens should be shared with sulfur. Same problem over here. The electrons of hydrogen should be shared with sulfur. So the one where that is where everything is facing in the correct direction is this one. So that's your answer. For 23, the degree of polarity in the bond between a hydrogen atom and an oxygen atom in a molecule of water can be assessed using the difference in their electronegativity. Please make sure that you pay attention to the question. If the question is asking for the difference or the polarity of the bond, take the electronegativity difference. If the question is asking for the polarity of the molecule, do the symmetry test. So remember, SNAP. If your molecule is symmetrical, it's nonpolar. If it's asymmetrical, it's polar. So which type of bond forms when electrons are equally shared between two atoms, meaning the molecule is symmetrical, or there's no difference in the electronegativity? It's talking about the bond. So that will be a nonpolar covalent bond. There's no two different poles. Everything's the same. An atom of which element bonds with an atom of hydrogen to form the most polar bond? Because we are looking at the most polar bond, we are looking for the one that has the highest electronegativity difference. So go ahead and find the electronegativity difference between these elements and hydrogen, and look at the one that has the highest difference. Ideally, you should be able to answer this question in like 2 seconds, because we should all remember that fluorine is the most electronegative element on the periodic table. It has an electronegativity of 4.0, so that should have the highest difference. So state the molecular polarity for each of the reactants in this equation. So hydrogen we drew earlier, so we do know that hydrogen is polar because it is asymmetrical. If you look at carbon dioxide, we have carbon here, 1, 2, 3, 4 valence electrons. And each oxygen has 1, 2, 3, 4, 5, 6. Now, technically, each oxygen should make 2 bonds to have a complete octet. So the bonds are going to look something like this. So that means if I draw this nicely or neatly, then each carbon has 2 bonds with the oxygens. So when you do the symmetry test, both sides kind of look the same. Both sides kind of look the same. So carbon dioxide is actually going to be nonpolar because it's asymmetric. Sorry, symmetric. Explain in terms of distribution of charge why a molecule of compound 1 is polar. So if it's polar, that means this should be asymmetrical. However, please do not say that this is asymmetrical, because the question is saying that explain in terms of distribution of charge. So if you write asymmetrical, your answer will be incorrect. You should say that the charges are distributed equally, or there's an equal distribution of charge. So state the number of electrons shared between the nitrogen atom and one of the hydrogen atoms in an ammonia molecule. So here you have, we did make ammonia before, looks like this. So the question is saying if we only focus on the bond between nitrogen and one of the hydrogens, so this one right here, how many electrons are shared? So that will be 2 electrons. How many electrons are shared in a triple bond? So triple bond is the one that is represented by 3 lines. So remember, each bond represents 2 electrons. So this will be 3 pairs. But because the question is not asking for the pairs, so you will say in total 6 electrons. So that was the bonding unit. Moving on to some chemical quantities. Which 2 terms represent the types of chemical formulas? So we can either have an empirical formula, which is the simplest ratio, or we can have the molecular formula, which is the actual formula for a compound. Which term represents the fixed proportion of elements in a compound? So if you're talking about a proportion that is not simplified, then that will be your chemical formula / molecular formula. Which term represents the simplest whole number ratio of atoms of the elements? That will be then your empirical formula. So here is one very quick example. If I'm looking at C2H6, this will be your molecular formula, and so the empirical form of this will be CH3. What is the molecular formula for? I shouldn't have done the example because here we have an example. So this right here is actually, no, never mind. This is not the example of going from empirical to molecular. This is just condensed formula, which is something specific to organic chemistry. So in the molecular formula, what we are going to do is we'll combine all of the carbons, hydrogens, and oxygens together. So if you count, we have 1, 2, 3 carbons. So that means 1 and 2, or did I miss one? Okay, 4. So 1 and 2 is not your answer. Then we have 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens, both 3 and 4 have 8. And then we see 2 oxygens, so that will be option 4. Then we have to write the empirical formula for this compound. Let's first write the molecular. So we have 1, 2, 3, 4 carbons. We have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, and we see 2 oxygens. So the empirical form of this, which is the simplest ratio, is going to be C2H4O. Determine the molecular formula for a compound that has the empirical formula CH2O and a molar mass of 180 grams per mole. So to go from empirical formula to molecular formula, there are a few steps that you need to take. First, find the mass of your empirical formula. So this should be 12 plus 2 for hydrogen and 16 for oxygen. So that is about 30. And then we take 180 grams per mole, which is the mass of the molar mass, or the mass of the molecular formula, and we divide that by 30 and get the ratio. So that will be about 6. That means what we're going to do is we'll multiply this empirical formula with 6. So that should be C6H12O6. Let's look at a few more questions. So which term represents the sum of the atomic masses of the atoms in a molecule? So this is going to be your formula mass, because it's the sum of the atomic masses. So let's say I have H2O. The mass of the 2 hydrogens is 2, and the mass of 1 oxygen is 16, so that is 18 grams per mole. This is your formula mass, or gram formula mass, or molar mass. We use multiple names for this. So 1 mole of bromine gas has a mass of, so you just have to calculate the gram formula mass, because this is Br2, so make sure that you multiply the mass of bromine by 2, so that you get the mass of 2 bromines. So 1 bromine is about 79.9, so 2 bromines will be about 159.8. Determine the formula mass of heavy water, which is D2O. So D is actually hydrogen with a mass of 2. There will be context for this question that will be given on the Regents exam. You're not supposed to know that D is supposed to have a mass of 2. So we have 2 of those, and then we have a 16. So when you add these, you get 20 grams per mole. What is the gram formula mass of magnesium nitrate? So we have 1 magnesium, which has a mass of about 24. And then we have 2 nitrogens. So 1 nitrogen has a mass of about 14. We are going to go ahead and multiply that with the 2. And then for oxygen, we have 3 times 2, 6 oxygens. So 1 oxygen has a mass of 16. We multiply that with the 6. So that gives us about 148 as our answer when we add them. We add the plus sign. Compare the formula mass of the 2 compounds in this equation. This is once again a compare question, so you can simply just say which one's higher, which one's lower. Just a very quick trick in this question, however, is that if you notice, it looks like these 2 formulas are almost the same. So in the first one, we see 2 nitrogens, 4 hydrogens, 1 oxygen, and 1 carbon. If I look at the second one, I see 2 nitrogens again. I see 4 hydrogens, and I see 1 carbon and 1 oxygen. So if the formulas are the same, then the formula mass is also going to be the same. To answer this question, you'll just say they have same chemical formula. Sorry. They have same chemical formula, so they have same formula mass. So what is the number of moles of carbon dioxide in 220 gram sample of carbon dioxide? So in this case, this is very common in Regents where they kind of try to save your time and they give you the gram formula mass. If it's not given, you have to calculate this yourself. So this is where we are trying to go from the given grams to the number of moles. Few ways to do this. You can use the equation given in table T. The equation, I believe, is called mole calculation. Or you can simply just do the dimension analysis. So if you have 220 gram sample and you multiply this with the molar mass or the gram formula mass, we know that 1 mole of this substance has 44 grams. That is what this tells us. So that is just 220 divided by 44. That gives you about 5 moles. So here's your answer. What is the number of moles in a 78.8 gram sample of magnesium carbonate? Same thing. Once again, we are going from grams to moles. So you can do dimension analysis. So just 78.8 divided by 84.3. So that is about 0.935 moles. Alright, then based on the lab data, show a numerical setup to determine the number of moles of oxygen produced. Use 32 grams per mole as the gram formula mass of O2. So we are trying to once again do the same thing. The only difference is that here you kind of have to hunt down the mass of oxygen that was produced. So here is the mass of the oxygen that was produced, 0.80. So when you set this up, these are your grams. We know 1 mole has 32 grams. So there's your setup. The question does not ask for the answer. It's only numerical setup, so you don't have to calculate. Based on the lab data, determine the mass of KCl produced in this reaction. So if you look at the lab data, first we are calculating the mass of the crucible and the cover, and then crucible, cover, and KClO3. So when you subtract these two, you get the mass of KClO3. Then you take the crucible and the cover and the KCl after heating. So after you heat the KClO3 sample, the oxygen disappears and you are only left with the KCl. So what we can do here is that we can go ahead and subtract this mass from this one. So we'll just do 23.41 minus 24.21. And that gives you, sorry, should be the other way around because mass cannot be negative. So that should be about 0.41, about 0.8. Actually, 0.8 is the oxygen that was evaporated. So that means whatever was left was actually just KCl. So my apologies, we are not subtracting that mass. We are subtracting the empty crucible and the cover from this. Why am I picking the wrong thing? Okay, there you go. So after we get rid of the crucible and the cover, we are only going to be left with the mass of KCl. So that one should be 23.41 minus 22.14. That's about 1.27. So your answer is 1.27. Let's get a few more questions. So we have a solution that contains 25 grams of KNO3 dissolved in 200 grams of water. What numerical setup can be used to calculate the percent by mass of KNO3 in the solution? So the equation for percent composition by mass is given in table T. All you have to do is write the mass of the part on the top. So in this case, your part is this, and write the mass of the whole at the bottom, multiply with 100. Now the problem here, or the trick here, is that when you write the mass of the whole at the bottom, 200 grams is only your water. That's not the whole thing. So your overall solution is going to be the mass of that water and the mass of the solute that you are putting in. And then you multiply with 100. So the correct answer in this case is going to be this one, not this one. For number 17, the percent composition by mass of nitrogen in the compound N2H4. So in this case, what we're going to have to do is look at the gram formula masses, or the molar masses. So we have 2 nitrogens. So that will be about 28, because 1 nitrogen is 14. So we do 28 divided by 32, which is the mass of the whole thing, times 100. So that should give you about 87.5, which can be rounded to 88. And then lastly, show the numerical setup for calculating the percent by mass of NaCl in the rock salt sample. So this is how much NaCl we had, but we also have the mass of beaker here. So let's go ahead and subtract the mass of the beaker first. So subtract 224.2. So 240 minus 224.2. That gives you about 15.8. So now if 15.8 is the mass of the sodium chloride, and 16.4 was the overall rock sample, that's your numerical setup for calculating the percent composition by mass. So let's move on to the chemical reactions. First of all, you must know what a chemical reaction looks like. So these are your chemical changes, not the phase changes. So that means the first 2 options are not your answer. O2 going from liquid to solid is not your answer. That's also a phase change. So O2 becoming O3. Now the chemical composition is changing, so that's a chemical reaction. With solutions produce the react to produce an insoluble compound. So first of all, when you see 2 compounds in your reactants, that is going to be a double replacement reaction. So that means the metals are going to replace each other, or maybe you can say the non-metals are going to replace each other. So in this case, the problem is that your non-metal is the same. So even if the metals replace each other, you still end up with KCl and LiCl. So this reaction is most likely not even going to occur. So you don't need to worry about that. In the second one, when you switch lithium and sodium, you end up with lithium nitrate, and you have sodium chloride. So now the question is saying we are looking for an insoluble compound as a product. So to figure this out, I hope you all remember, we go ahead and use the beautiful table F. So table F tells you which compound or which ions are going to make soluble or insoluble compounds. So chlorides or halides in general are soluble unless they combine with silver, lead, or mercury, which is not happening here, so this one is soluble. The nitrates are in general soluble as well, and there are absolutely no exceptions to that, so this is also soluble. If you look at sodium chloride and silver perchlorate, we have, when they both switch, we end up with sodium perchlorate and silver chloride. So perchlorates in general or chlorates are soluble with no exception, so this one will be soluble. Silver chloride, as we mentioned earlier, halides are soluble unless they combine with silver, lead, or mercury. So in this case, this is going to be insoluble. So your answer is 3. And once again, this was table F. Which equation represents a spontaneous reaction? So spontaneous is the one where you have a more active metal replacing a less active, because less active cannot on its own spontaneously replace a more active thing. So you have to use table J to compare the reactivities. So in the first example, we have calcium trying to replace barium. Or you can also think about your oxidation reduction reaction in this case if you're not sure which thing is losing and which thing is gaining. So because calcium seems to go from 0 to +2, that means calcium is losing electrons, it's becoming more positive. So that means calcium is trying to replace barium. So can calcium lose its electrons? Let's compare calcium and barium using table J. And it looks like barium is more active than calcium. So this one is actually non-spontaneous. Cobalt and zinc, when you compare them, zinc seems to be more active. So once again, this one is non-spontaneous. Then iron and magnesium. Once again, magnesium is more active. So this is non-spontaneous. And when we compare manganese and nickel, in this case, manganese is more reactive. So this is the one that's going to be spontaneous, because that means manganese can lose electrons to nickel. So this reaction is classified as we see two compounds reacting. They are switching their metals and converting into two compounds. That one will be a double replacement. Which type of chemical reaction is represented by this equation? We see one element and a compound, and then we only see one thing replacing the other, and we are left with one element that is alone. So this type of reaction is a single replacement. And then just a very, very quick review for everyone for the other type of reactions. If you see two elements combining to make a compound, that is synthesis. If you see a compound breaking down into individual elements, that will be decomposition. And then we have combustion, which is a carbon-based compound that reacts with oxygen. I'll say carbon something, that reacts with oxygen to make carbon dioxide and water. So compare the chemical reactivities of nitrogen and argon based on Sarom's experiment. So this is an example of a question where you have to read the text that comes before. So what we are looking at in this experiment is that they separated nitrogen gas from the air and reacted it with an excess of magnesium, producing solid magnesium nitride. And then they were able to find the unreactive gas, which was argon. So you can say that based on this experiment, nitrogen was more reactive. That's all that you have to say. Next up, we have explain in terms of substances why the reaction is a decomposition reaction. So because it says in terms of substances, yes, you can say that something is breaking, but you have to be more specific. So you have to say that we have a compound that is breaking into a compound and an element. So now you have named the substances. So which quantities are conserved in all chemical reactions? So that should be your mass, charge, and energy. Something that should be on your fingertips. That's the law of conservation. Which equation represents conservation of atoms? So that means which one is balanced. So we are looking for an example where we have same number of atoms on both sides. So that seems to be option 4. The unbalanced equation below represents the reaction. So we have to balance using the small whole number ratio. So remember, all you have to do is start counting the elements. So we have 2 silvers on this side. Let's go ahead and make 2 silvers on the other. 1 sulfur here, but we have 3 sulfurs here. So now remember, we cannot go ahead and add a subscript. We can never add a subscript when balancing. All that we can add is a coefficient. Now the problem is, when we add this coefficient, that changes the number of silver, because now we have 6 silvers on this side, so that means we should have 6 on the other side. So let's change this to 6. And then for aluminum, we have 1 here and 2 there, so let's make this a 2. So now let's count everything again one last time. I see 6 silvers on both sides, 3 sulfurs, and 2 aluminums. So we're good. What is the mass of magnesium nitride that is produced when 14.58 grams of magnesium completely reacts with 5.6 grams of nitrogen? So in this case, if you have 14.58 of magnesium and you have 5.6 of nitrogen, all you have to remember is the law of conservation of mass, which means the mass should be the same on both sides. So if this is the total mass that you are using, then this should be the total mass that you are producing. So to answer a question like this, all you have to do is add the masses. So that should give us 14.58 plus 5.6. That should give us about 20.18 grams. And then similar question, what's the mass of N2 produced when we have 1 gram of hydrogen completely react with 15 grams of NO to produce 9 grams of water? So the total mass on this side is 16. That means the total on this side should also be 16. So you can just do 16 minus 9, and that should give you how much nitrogen is produced. So that's about 7 grams. And you don't have to worry about the coefficients or anything in this case. So determine the number of moles of boric acid that react in the equation to produce 10 moles of water. So now we are, instead of comparing the mass, we are comparing the moles. So we are saying that we have 10 moles of water that are produced. In the actual equation, we only have 5. So the easiest way to answer this question is to use dimension analysis. If start with what's given in the question, which is 10 moles of water, and the question is asking you to compare water and boric acid, which is right here. So you just compare their mole ratios. So according to the equation, for every 4 moles of boric acid, we need 5 moles of water. So now that you have the correct setup, we can just go ahead and do the math. So 10 times 4, that is 40, divided by 5, that gives you 8 moles of boric acid that will be produced if we have 8 moles of boric acid that we need if we want to produce 10 moles of water. So similar question, how many moles of carbon dioxide are produced when 5 moles of butane react completely? So we are comparing butane and carbon dioxide. Start with what's given in the question, which is 5 moles of butane. Use the mole ratio between carbon dioxide and butane. Butane, by the way, is this. It will be mentioned in the question somewhere. I just didn't give you the complete information. So that will be, we need 2 moles of butane for every 8 moles of carbon dioxide, according to the equation. So that would be 5 times 8, which is about 40, divided by 2. So we need, we produce 20 moles of carbon dioxide. And once again, a very similar question, how many moles of potassium chlorate must completely react to produce 6 moles of oxygen? Similar thing, start with 6 moles of oxygen and multiply with the mole ratio. For every 2 moles of KClO3, we produce 3 moles of water. 3 moles of oxygen. So that will be 6 times 2, which is 12, divided by 3. That gives us about 4 moles. Next up, we are going to look at the states of matter in a little bit more detail. So at STP, two forms of solid carbon and diamond have different properties because they have different chemical composition, and they also have different structures. So let's look at the options. Diamond has a different percent composition than graphite. Diamond has more electrons per atom than graphite, which is not true because we know they are both made of carbon. Diamond has stronger hydrogen bonding than graphite. Could be true. The question kind of doesn't quite give us enough information. Diamond has a different crystal structure than graphite. So the 1% composition is also something that we don't have enough information for in the question because we don't know the formula. And then for the hydrogen bonding, we know that it's made of carbon. We don't know if there are any hydrogens, right? So we don't know if there is any hydrogen bonding. So that is also something that we don't have information for. So the only option here is number 4. So which property is determined by the structure, arrangement, and interaction of the molecules of a substance at a given temperature and pressure? So all of these things can give us information about the phase of matter or the physical state of a substance. Which sample of matter has the greatest distance between molecules at STP? So greatest distance is very specific to gases. Sample of KCl solid is dissolved in water to form KCl aqueous solution. When the water in KCl is completely evaporated, KCl solid remains. Which statement describes the property of KCl solid after the water evaporated? So the KCl becomes a molecular compound. Well, that means KCl is not KCl anymore, so that's not true. The molar mass of KCl decreases. No, it will not, because it's still KCl. Same formula, so molar mass is not impacted. Melting point of KCl is unchanged. That is also something that depends on the identity of the substance. So as long as it's still KCl, melting point will not change. KCl conducts an electric current. KCl solid conducts an electric current. This is something that could be impacted because we said that in ionic compounds they don't conduct when they are a solid, but they do conduct when they are in the aqueous solution. So identify the substance in this table that is a liquid at STP. So we are given, the only thing that we have here to make a comparison is the melting points and the boiling points. We do know, based on our prior knowledge, that some of these things, fluorine, bromine, iodine, we know they are gases. Bromine is a liquid, by the way. We know for sure fluorine is a gas. So what you do need to know, however, is that as the particles come closer together, their melting and boiling points increase, because then it's harder to separate the particles to change their phase, or to break the intermolecular forces to change the phase. So when we go from gas to liquid to solid, the boiling point and melting point increase. So if you're comparing maybe gases and liquids here, actually they did not specify if you're only comparing gases and liquids. Interesting. Okay, well, this is something that you do have to remember, keep in mind. There was most likely some information before this that I did not put in the question that would have been more helpful, but something that we did write in our notes that you should write in your notes if you don't have it already is that bromine is one of the only 2 liquids at room temperature. So your answer will be bromine in this case. The other liquid, by the way, is mercury. State how the molecular motion of the water molecules in the beaker changes as the temperature increases. So remember, temperature is defined as the measure of kinetic energy. So when we are increasing the temperature, that means we increase the kinetic energy of the molecules. So that means now they are going to start moving faster. So that's your answer. Just have to say that the molecules or the particles start moving faster. Which term identifies the strong intermolecular forces found in a sample of liquid water? So we have got 3 different types of bonding. Remember that bonding is not intermolecular force, because bonding is intramolecular. It is between or within the same molecule. Intermolecular forces are between different molecules. So the only intermolecular force here is hydrogen bonding. Which statement explains the low boiling point of hydrogen at standard pressure? So hydrogen has strong covalent bonds. Hydrogen has, it doesn't have covalent bonds, at least not strong, because it has non-polar when you have 2 hydrogens. So hydrogen has weak covalent bonds, hydrogen has strong intermolecular forces, hydrogen has weak intermolecular forces. So we don't need to look at the bonds in general, because boiling point is mostly impacted by the intermolecular forces. So if something has a low boiling point, that means the intermolecular forces are weak. So let's make a note of that as well. Low boiling point means low intermolecular forces, because that means it is very easy to break those intermolecular forces and change the phase. What's the vapor pressure of water at 90 degrees Celsius? This is something that you are going to have to answer using table H. So you can just look at table H, go to 90 degrees Celsius, go to water, find the vapor pressure. Based on table H, once again, which compound has the strongest intermolecular forces at 60 kilopascal? So in table H, at 60 kilopascal, the substance that has, okay, so table H can give us information about the vapor pressure and also about the boiling point. So if you're looking for strong intermolecular forces at this specific vapor pressure, then we are looking for the one that has the highest boiling point. So according to table H, the one that has the highest boiling point is ethanoic acid. Based on the boiling point, compare the strength of intermolecular forces in 1-chlorobutane and the strength of intermolecular forces in 2-chlorobutane. So once again, that's a comparison question. So you can simply say which one has a higher boiling point. I'm sorry, which one has stronger intermolecular forces. So because 1-chlorobutane has a higher boiling point, that means this one is going to have stronger intermolecular forces. Based on table I, which equation represents conservation of mass and energy? So to answer this question, you're going to have to go to table I and look at the equation for the combustion of methane. So that, I believe, is the very first equation in table I. And the energy or the heat for that reaction is negative 890.4. So if your delta H is a negative number, that means it's an exothermic reaction, and the energy should be written in the products because it's released. So 1 and 3 is not your answer. So now that we know it's either 2 or 4, the other thing that we need to compare is the mass. So which equation is balanced correctly? So that seems to be, you just have to see if you have same number of carbon, hydrogen, and oxygen on both sides. So that seems to be equation number 4. What is the amount of heat released by 1 gram of liquid water at 0 degrees Celsius when it changes from 1 gram of ice at 0 degrees Celsius? So we are looking at a phase change from water to ice. So that is freezing. And we are trying to figure out how much heat is going to be released when we go from liquid water to solid water. So the equation that you're going to use in this case, remember we had 3 equations for heat. You either have Q equals MCAT, that we use whenever there's a difference in temperature, which we don't see here. So that means we have to use one of the other two equations, either the one with heat of vaporization or the one with heat of fusion. So freezing is the opposite of melting, so that means we're gonna have to use the equation with heat of fusion. So Q equals MHF. Because it's just water, the heat of fusion of water is given in table B. It's about 334 joules per gram. So you just multiply that with the given mass, which is 1. So the answer in this case is 334 joules. So determine the mass of liquid water that vaporizes if 7,700 joules of energy is absorbed by water at 100 degrees Celsius. So in this case, we are not actually calculating the heat energy, we are calculating the mass. And we are looking at a phase change, so that means we don't use Q equals MCAT. The equation that we are going to use in this case is the one with heat of vaporization. We are looking for mass, so the equation, when we rearrange this, is just going to be Q divided by heat of vaporization. So Q is given to be 7,700, and we divide that by the heat of vaporization, which is 2,260 joules per gram. So joules cancel with the joules. When you do the math, you get about 3.4 grams. Use information on table B to determine the amount of heat absorbed by water when the water is heated from 20 degrees Celsius to 50 degrees. Because in this case, we do see a difference in temperature. So this is a good example of when we use Q equals MCAT. So the mass in this case is not given, which is interesting. So it looks like this is another example of a question where I forgot to include the text that was given before. So let's assume that the mass was given to be 10 grams. The C is given in table B. The specific heat capacity of water is 4.18 joules per gram degrees Celsius. And then your difference in temperature, remember it's always final minus initial. So we are going to 50 degrees Celsius, so 50 minus 20. If you do initial minus final, you get the wrong charge. So please don't do that. So now we just do the math and calculate the answer. Should be a positive number. During which two processes does a substance release energy? So very quick thing that you can remember is if, let's say, we are starting from a solid and we are converting that to a liquid and then to a gas. In this case, we are trying to move the particles away from each other. So these absorb heat. If, however, we are going from the gas to the liquid to the solid, now we are bringing the particles closer together. So in this case, they are going to release the energy. So the question is asking for something that is releasing, so we can look for something that is, we have freezing, which is going from liquid to solid, or condensation, which is going from gas to liquid. So that is your answer. For the next two questions, we are given a heating curve. Just a very quick reminder, heating curve means we are adding heat over time. So in this case, we are starting with a solid, and then we go to a liquid phase and then to the gas phase. The straight lines represent the phase change. And then remember, the temperature associated with the phase change will be your melting and boiling point. So identify the interval during which the average distance between the particles is the greatest. So that will be your gas phase. So the interval is EF. State what happens to the potential energy of the particles during the melting of the substance. So melting is just one example, but during any phase change, the kinetic energy remains the same, as you can see, because it's a straight line, no temperature change, so no change in kinetic energy. But for the potential energy, it increases or decreases depending on whether we are doing something that absorbs energy or releases energy. So when we are melting something, we are going from the solid phase to the liquid phase. So in that case, we are going to need energy, absorb energy, to move the particles apart. So the potential energy is actually going to increase in this case when the phase change is occurring. So potential energy increases in a heating curve and it decreases in the cooling curve. Now let's go ahead and talk about some gas laws. So which statement describes the particles of an ideal gas based on the kinetic molecular theory? So remember, kinetic molecular theory says that particles move in a constant, random, straight line motion. They have negligible volume and they have negligible intermolecular forces. And lastly, when they collide, their energy, the overall energy still remains the same. They just transfer their energy from one body to the other. So if you look at these options, the volume of the particles is considered negligible. That is something that kinetic molecular theory said. Forces of attractions are strong. Not what KMT said. Particles are closely packed. Not at all, because they are gases. Particles are separated by small distances relative to their size. This is similar to number 3. And again, particles have a huge distance between them. According to kinetic molecular theory, ideal gas particles are separated by small distances. No, do not transfer energy when they collide. They do have attractive forces. No, kinetic molecular theory said they have negligible intermolecular forces. They do move in random, constant, straight line motion. According to kinetic molecular theory, an ideal gas has particles with large volume, large atomic nuclei, no attractive forces, no random forces. That will be, no random motion. That will be no attractive forces. At which temperature and pressure will a sample of neon gas behave most like an ideal gas? So remember, kinetic molecular theory said an ideal gas is something that has no volume and no IMFs. So the only way that a gas can behave like an ideal gas is if it has very little volume or very little intermolecular force, which is only possible if, and you must memorize this, so this is only possible when we have very, very high temperatures, because now the particles are moving very fast, so they have very little attraction between them, and it's hard for them to occupy any space because they're just all over the place. And then if we also have very low pressure, now there's a lot of distance between the particles, so we can't really say what is the volume of the gas because it's not occupying the entire space. And also because they are so far away from each other, they have little to no intermolecular forces. So we are looking for the highest temperature and the lowest pressure in this case. So that will be option 3. State one change in temperature and one change in pressure that will cause the gas in a cylinder to behave more like an ideal gas. That is this answer that we just wrote. At STP, which gas has the same number of molecules as 2 liters of CH4 at STP? So remember, according to Avogadro's law, if we have 2 gases at STP, no matter what those gases are, their volume is going to be the same. So we are looking for any gas that has the same volume. So your answer will be 2 liters. Which 2 samples contain the same number of molecules? So once again, according to Avogadro's law, the gases that have same volume have same number of molecules. Doesn't matter what gases they are. So gas number 1 and gas number 3, they have same volume. So that means they have same number of molecules. 2.5 liter sample of SO2 gas at STP and a 2.5 liter sample of carbon dioxide at STP can be differentiated by comparing their so they are 2 different gases, but they are both at STP and they both have the same volume. So how can we differentiate between them? If we compare their masses, there's no information about the masses, so we don't know. Their phases are the same, their temperatures are the same, and their volumes are the same. So coming back to the masses, what we can assume is that they are talking about the molar masses here. So because they are different gases, they are going to have different molar masses. So that is something that we can use to differentiate. At STP, which property can be used to differentiate 1 mole sample of chlorine and krypton? So their phase, no, because they are both gases. Pressure, they're both at STP. So no pressure, no temperature. So we can go ahead and compare their chemical reactivity because krypton is a noble gas, so it doesn't react. Which graph represents the relationship between pressure and volume for an ideal gas at constant temperature? So remember that pressure and volume are going to be, according to Boyle's law, when we increase the pressure, the volume decreases because now we have less space. So there's an indirect relationship between pressure and volume. And just remember that that indirect relationship is not going to be a linear line. It's this exponential function. All right. I apologize for my neighbor's dog. So explain in terms of particle volume why the volume of helium cannot be compressed by the piston to zero volume. So you can say, to answer this question, that the particles are going to occupy some volume, even if it's very little, but as long as there are some particles, they do occupy some space. State what happens to the average distance between the helium atoms as the gas is heated. So when we heat the gases, we are increasing the kinetic energy. So average kinetic energy increases. And so the particles are going to move more vigorously and the average distance is going to increase, of course, if they have more space. But you can just in general say that the average distance between the particles is going to increase. State what happens to the average kinetic energy of the gas particles if the cabin temperature decreases. So if temperature is decreasing, average kinetic energy is also going to decrease. Particles start moving slower. Show a numerical setup for calculating the pressure in the submarine cabin if the cabin temperature changes to 293 Kelvin. So it looks like we are comparing the temperature and the pressure. So according to, if you don't remember the equations for each gas law individually, you can always use the combined gas law. Just ignore the thing that is not changing and plug in the values for the things that are changing. So what we do know from the question is that okay, so this right here is actually 2.4 times 10 to the power of 5, which is actually about 240,000 liters. So as people in the cabin breathe, carbon dioxide gas can build up to safe levels. Okay, so it doesn't look like, according to the passage, the volume is changing, so we can just ignore that. The temperature was initially 312, and now we changed the temperature to 293. So let's go ahead and plug in the temperatures. Initial was 312. Final is 293. We need to know the final pressure, and the initial pressure was about 116. So you can just go ahead and solve for x, or leave it like this because it only asks for the numerical setup. So convert the original air pressure in the cabin of the submarine to atmospheres. So remember, 1 atmosphere is equal to 101.3 kilopascal. This is something that you should memorize, but you can also get this information from table A. So you can just use dimensional analysis, multiply 2.4 times 10 to the power of 5 with, so this is Uh-oh, I used the wrong thing. I used the volume. You should have 116 kilopascals. So multiply this with 1 atmosphere is equal to 101.3 kilopascal. So just do the division and get your answer. State in terms of average distance between the helium atoms why the density of gas increases when the piston is pushed further into the rigid container. So what happens is that when you are pushing, when you are increasing the pressure, remember that the equation for the density is mass over volume. So when you are increasing the pressure, the volume decreases, but the mass stays the same. So to answer this question, you can just say the mass stays the same, but the volume decreases, which is why the density increases, because density and volume, according to this equation, are indirectly related. Compare the number of helium atoms in the cylinder at a pressure of 0.5 atmosphere to the number of helium atoms in the cylinder when the pressure is increased to 1.5 atmosphere by pushing the piston. So in this case, we are comparing the number of atoms with the pressure. So here's the thing. We are only changing the pressure, but we are not adding or removing any helium atoms. So to answer this question, you actually don't have to do any math because it's the same number of atoms, as long as you're not removing any atoms or adding any. So determine the volume of a sample of carbon dioxide if the temperature and pressure are changed to 336 and 152. So this is an example of something where all of the quantities are changing. So you can use the combined gas law. So P1V1 over T1 equals P2V2 over T2. So plug in your numbers, get the answer. Compare the mass of original 200 milliliter sample of carbon dioxide to the mass of the carbon dioxide sample when the cylinder is adjusted to a volume of 100 milliliters. So in this case, we are comparing. Once again, this question is kind of similar to number 17. The mass of the sample is not going to change unless we are adding or removing any gas. So you can simply say that the mass is going to stay the same in this case as well. Next up, we are going to be looking at solutions. So at STP, which property can be used to differentiate a 10-gram sample of sodium chloride from a 10-gram sample of sodium nitrate? So the options are the mass of the sample, mass is the same, so that's not your option. Temperature of the sample, they're both at STP. Solubility, question doesn't say anything about solubility and they are different substances, so probably yes. Phase is the same, so not that, so it's the solubility. Which statement describes the solution of sodium chloride in water? So the mixture is heterogeneous, meaning we see different layers. So not really, because we know sodium chloride dissolves well. And the solute is sodium chloride and the solvent is H2O. So solute is the thing that is being dissolved, and solvent is the thing that causes the dissolving or that we are dissolving in. According to table F, which compound has a very low solubility in water? So just go to table F, read your table, see which one is insoluble. Based on table F, which 10-gram sample, when thoroughly mixed with 1 liter of water at room temperature, forms a heterogeneous mixture? So once again, we are looking for something that is insoluble according to table F. So that's why it's heterogeneous, because it can dissolve. Based on table G, what is the mass of KCl that must be dissolved in 200 grams of H2O at 10 degrees Celsius? So if you look at your table G, and if you look at KCl, whatever number you get is only going to be for 100 grams of water. So right now at 10 degrees Celsius, for KCl, I see about 30 grams. So 30 grams at or in 100 grams of water. But if you have 200 grams of water, then that means we should be able to dissolve double the amount of KCl. So that's about 60 grams. Based on table G, which sample when added in 100 grams of water and thoroughly stirred produces a heterogeneous mixture at 20 degrees Celsius. So heterogeneous mixture means we are looking at something that is already saturated. So you're looking for something that is either right on the line of saturation or above the line of saturation. So 20 grams at 20 of KCl at 20 degrees Celsius is going to be unsaturated, but 80 grams of KCl at 20 degrees Celsius is going to be saturated because that is way above the line. So state in terms of molecular polarity why urea is very soluble in water. So remember, we said that two things can only dissolve if they have the same polarity. So like dissolves like. This should not be your answer. So for your answer, you should just say they have similar polarity. Or you can say, we know water is polar, so you can say urea is also polar. But just remember the concept, like dissolves like. So based on table G, which compound has the greatest solubility in 100 grams of water at 10 degrees Celsius? So you're looking for the one that can dissolve the most mass. The greatest solubility means most mass dissolved. Then for number 9, based on table G, which compound is less soluble in water as the temperature increases from 0 degrees to 100 degrees Celsius? So we are looking for something that has a downward going arrow over time. So that is going to be, according to your table, NH3, which is a gas. Because remember, gases, if you increase the temperature, gases actually dissolve less because now they are able to move faster. So instead of staying dissolved, they would want to leave the solution if they can move more. Based on table G, determine the additional mass of NaNO3 that must be dissolved to saturate the solution at 23 degrees Celsius. So at 23 degrees Celsius, we already have 85 grams of NaNO3. And we need to dissolve about 90 grams to make a saturated solution to get to the line. So that will be about 5 grams more that we need. So state the solubility of limestone in water. So limestone is calcium chloride. Just go to table F to get this answer. See if calcium carbonate is soluble. Classify in terms of saturation the type of solution that is produced in this case. So we have 20 grams of ammonium chloride, and after thorough stirring, no undissolved ammonium chloride was left. So that means we have an unsaturated solution if everything dissolved. State in terms of aqueous ions why this tap water can conduct electricity. So remember, whenever something is able to conduct electricity, that means it has mobile ions, because electricity is only conducted when ions can move. So draw at least 2 water molecules in the there's no box here, but draw at least 2 water molecules showing the orientation of each water molecule towards the calcium ion. So here we have 1 water molecule, and here we have another water molecule. So if your calcium plus 2 ion is right here, then they should be, your oxygens should be facing towards the calcium, because remember, and we can also even write that here, that oxygen has a partial negative charge, hydrogens have partial positive. So the negative charges of the oxygens are going to attract the positively charged calcium. So state in terms of concentration of ions why the 6 molar HCl is a better conductor of electricity than 0.1 molar HCl. So quite simply, that is only because the 6 molar HCl has more mobile ions. So if you have more ions, that means there's going to be more movement in the solution, and so more conductivity. So 0.05 molar aqueous solution of which compound is the best conductor of electricity. So here we are talking about something that is able to break into ions so that we can have the movement of the ions. So the first thing right here, cannot break into many ions. This is not an ionic compound. This looks more like a covalent, because even if it breaks, what are the ions? We don't see any metals here, so that is not your answer. The second thing, similar thing, this is your glucose, a regular covalent compound, does not break into ions. Magnesium sulfate and potassium sulfate, they can both break into ions. So here's a competition. Magnesium breaks into magnesium, one magnesium, and one sulfate. Potassium sulfate breaks into 2 potassium ions and 1 sulfate ion. So because there were more ions in potassium sulfate, it breaks into 3 ions instead of 2, like magnesium sulfate. So that means this is going to be a better conductor. So what's the molarity of a sodium hydroxide solution that contains 0.125 moles of sodium hydroxide in 0.2 liter of water? So you just have to use the molarity equation, which is, remember, moles over liters. So just plug your moles over liters. So that should be 0.125 divided by 0.2, it's about 0.625. How many moles of Ki are needed to make 0.5 liters of a 0.2 molar aqueous solution? So we once again use the same equation, but this time we are solving for moles. So we just multiply the molarity and the liters. So 0.5 times 0.2, that gives us about 0.1 moles. Solution is prepared using 9.8 grams of sodium hydrogen carbonate in enough water to make 1500 grams of total solution. What is the concentration in parts per million? So in parts per million, we write the mass of the solute at the top. We write the mass of the solution at the bottom. We are lucky in this case because 1500 is the mass of the total solution. Sometimes they only give you the mass of the solvent. So in that case, you have to add the solvent and the solute. And then we multiply this with 1,000,000 and get your answer. So which term is used to express the concentration of an aqueous solution? Out of all 4, that should be parts per million. Compared to 0.1 molar aqueous sodium nitrate, at 1 atmosphere, a 1 molar aqueous sodium nitrate solution at 1 atmosphere has, so this one has a higher concentration, the 1 molar. So here are your colligative properties, which means the more ions you have in the solution, the higher the boiling point and the lower the freezing point. Make sure you memorize these. So lower freezing point and higher boiling point. State what happens to the boiling point and freezing point of that solution when the solution is diluted with an additional 100 grams of water. So now what we are doing in this case is that instead of adding more ions of the solute, we are adding more water. So when we add more water, that means now we are going to have less solute. So if we have less solute, that means the boiling point goes down. It's not going to boil faster because we have less ions, and it's going to freeze faster as well, so the freezing point goes up. This is the opposite of what we said for the previous question. So now let's talk about your thermochemistry. So what occurs when atoms of bromine react to form a molecule of bromine? So we have 2 atoms that are combining to make a molecule. So remember BARF, because in this case the bonds are going to form. So BARF means break, absorb, release, form. So when bonds are formed, energy is released. So your answer is a bond is formed as energy is released. Heat flows from an object to a temperature of 20 to an object at a temperature of. So remember, heat always goes from high to low. So we are looking for something that is lower than 20, so that should be 1. The heat of reaction is going to be always the heat of the products minus the heat of the reactants. Never the reactants minus products. Which term represents a disorder of the system? That should be entropy. Which phase change represents an increase in entropy? So remember, increase in disorderness that normally happens when particles are moving more. So when we go from liquid to gas, now particles are moving more. Liquid to solid, they are more organized. Gas to solid, they are more organized. Gas to liquid, again, more organized. Systems in nature tend to change toward. Most important question, should remember this. This is most likely going to show up. So systems in nature prefer the systems that have high disorder, randomness, and they require very little energy. So lower energy and greater disorder, or you can say lower energy and high entropy. What's the temperature in degrees Celsius of a sample of matter at 35 Kelvin? So equation is given in table T, but when we are going from degrees Celsius to Kelvin, you just do degrees Celsius plus 273. If you're given the Kelvin, then you do the opposite. So Kelvin minus 273, and that should give you the degrees Celsius. So that is about negative 238. Solid aluminum has a specific heat capacity of 0.9. How many joules of heat are absorbed to raise temperature of 24 grams from 300 to 350? So this is an example of a problem where we can use Q equals MCAT. Just plug in the numbers, plug in your Q. Sorry, you're solving for Q, so plug in your mass, which is 24, times specific heat, which is 0.9, times the difference in temperature, which is about 50 Kelvin. Remember, you do final minus initials, so 350 minus 300, that should be 50. So this is about 1080, which can be rounded to 1100. So based on table I, which equation represents a reaction with the greatest difference between the potential energy of the products and the potential energy of the reactant? So this right here is actually the definition of the heat of the reactant. So the question is only asking for the greatest delta H. So you are going to be looking at which one has the highest delta H value. Based on table I, which compound dissolves in water by an exothermic process? So based on table I, whichever thing has a negative delta H value, so you just look at the equations for dissolving in water. So that should look something like sodium chloride plus water is equal to something, or the other way around if it's a reverse reaction. So you should have a negative value for delta H, which list includes 3 forms of energy. So some examples that I see here are temperature, chemical, and thermal. That's a good one, because in the next one we see temperature, thermal, and alkalinity. That is just basicity, so that is not energy. Electromagnetic are just radiations, not energy. Then same thing for the next one. Those two are not energies. Greatest increase in entropy occurs when a 1 gram sample of water changes from, so entropy once again is randomness. So we are looking for more randomness, so that means we should go towards a more movement. Which form of energy is converted to thermal energy when propane burns in air? So because we are using chemical substances, so the chemical energy is the one that's converting. So compare thermal energy of a 10 gram sample of water at 25 degrees Celsius to the thermal energy of a 1000 gram sample of water at 25 degrees Celsius. So thermal energy is actually going to be your Q value, so which is also called the heat energy. So if you have more mass, the thermal energy is going to be higher. So you'll just say 1000 gram sample is going to have a higher thermal energy. State what happens to the potential energy of the molecules in a solid sample of hexane at -5 degrees Celsius as heat is added until the hexane is completely melted. So this is kind of referring to your heating and cooling curves. So we are heating in this case while we are melting. So remember, the potential energy goes up during the phase change. So here we have the potential energy diagrams. What can be concluded from this diagram that we see above? So is it exothermic or endothermic? We see that this is the heat of the reactants. Actually, let me write that like this, and this is the heat of the products. So we see that the heat of the products is greater than the heat of the reactants. So when we do the subtraction, we should end up with a positive delta H. So that means this is an endothermic reaction. We have absorbed a lot more heat and released a lot less. So this is endothermic with a positive delta H. Which numbered interval represents the activation energy? So activation energy means how much energy do we need to go from the reactants to the top. So that should be this difference right here. What's the amount of heat required to melt 43 grams of solid magnesium oxide at its melting point when the heat of fusion is this? So we are using the equation with the heat of fusion. So just multiply the heat of fusion with 43. You should get your answer. Which numbered interval represents the heat of the reaction? So heat of reaction, as we have said earlier, is the heat of the products minus the heat of the reactants. So that is the difference between your products and your reactants. So that should be this number right here. When ice melts at 0 degrees Celsius, entropy increases because we are going from solid to liquid. So that means average kinetic energy of the particles is increasing. So they are moving more. But also, interesting. So average kinetic energy is actually not going to change because we are at the same temperature. So average kinetic energy will not be impacted. In fact, particle arrangement becomes more random. So state evidence from table I that indicates that this dissolving process is endothermic. So you are looking for the dissolving of ammonium chloride. Go ahead and look at the equation for ammonium chloride dissolving in water. Ideally, you should see delta H as a positive value, and that's your answer. The delta H is positive. Compare the average kinetic energy of helium atoms in a sample of 200 Kelvin to the average kinetic energy of helium at 300 Kelvin. So 300 Kelvin is a higher temperature, so this is higher average kinetic energy. Determine the net quantity of heat released when 1 mole of ammonia gas is produced by this reaction. So for this one, you're going to have to look at table I again and look at the equation for this reaction. And whatever answer you get there, if it's not for 1 mole of ammonia, so let's say it's for 2 moles of ammonia, you're going to divide that delta H by 2. But if it's only for 1 mole of ammonia, then that is your answer. Draw a potential energy diagram for this reaction. Wow, I cannot do this until I look at table I. Okay, so based on table I, to produce ammonia, so we produce 2 moles of ammonia when delta H is negative 91.8. So for 1 mole of ammonia, I'll just do 91.8 divided by 2. So that gives me negative 45.9 kilojoules per mole. So this is an exothermic reaction. So when I draw the potential energy diagram, I am going to make sure that I show that if our reactants are starting from here, they absorb very little energy and they release a lot more energy. So this is roughly your potential energy diagram. So state in terms of activation energy and reaction pathway why the addition of a catalyst increases the rate of the production of ammonia. So remember, whenever you add the catalyst, it says in terms of both activation energy and reaction pathway. So you have to say that activation energy goes down and there is an alternate reaction pathway. So if I have to draw that over here, that should look something like this. So determine the energy of required to break all the bonds in 0.25 moles of hydrogen-hydrogen bonds in H2. So the question is telling you that the bond energy of HH is this one. And this is how many kilojoules we need for 1 mole. So if we only have 0.25 moles, then I can just go ahead and multiply that by 436 kilojoules per mole, and that should give me the answer. Show a numerical setup for calculating the amount of heat in joules absorbed by the water in the beaker as a result of the burning candle. So for something like this, because you do have a initial and final temperature, so you can once again go ahead and use Q equals NC delta T. So plug in the mass, which is right here, plug in the difference in temperature, and then for C, that will be 4.18 for water. Compare the entropy of a sample of dinitrogen tetroxide gas at 25 degrees Celsius and 1 atmosphere to the entropy of the same sample of dinitrogen tetroxide as at 15 degrees Celsius and 1 atmosphere. So what we are looking at here is that the pressure is the same, but one of them is at a higher temperature. So you can say the one at 25 degrees Celsius, because it's a higher temperature, that means particles are moving more, so there will be a higher entropy. So now let's talk about the equilibrium. A reaction is most likely to occur when the reacting particles collide with proper energy and proper orientation and proper energy. So this right here is your collision theory. With sample of HCl reacts at the fastest rate with a 1 gram sample of iron filings. So we are comparing the concentrations here. So out of 1 mole and 3 mole, if you have a higher concentration, that one is going to react faster. So, and then if you have a higher temperature, if you have a higher temperature, then that is also going to react faster. So right here is your correct answer. What combination of reactants would result in the fastest reaction? So we have 1 gram sample of zinc. So we either have the strip of zinc or the powdered zinc. Remember, if you have a strip, you have less surface area. If you have powdered form of anything, that is more surface area. So more surface area is going to react faster. And then we are comparing the molarity. So the higher the molarity, the faster something reacts. Hydrochloric acid reacts faster and powdered zinc than with powdered zinc than with an equal amount of zinc strips, because the greater surface area of the powdered zinc decreases frequency, decreases activation energy, increases the frequency of the effective collisions. So state some changes in reaction conditions that will increase the rate of this reaction. So you can say anything along the lines of increasing the concentration of something, so adding more zinc, adding more hydrochloric acid. You can say adding a catalyst. You can say changing the temperature. So any of those options will be correct. Explain why this reaction will not reach equilibrium. The reason why this is not going to reach equilibrium is because we only see a single arrow. That means because we are producing this hydrogen gas, so when the hydrogen gas escapes, we will not have the reactants to do the reverse reaction. So you can say that the hydrogen gas can escape and there will be no reverse reaction. According to which theory or law is a chemical reaction most likely to occur when two particles with the proper orientation and energy interact with each other? So that is your collision theory. Which statement describes concentration of the two gases in the system? So if they are at equilibrium, that means concentrations must be constant, not equal, constant. What change will cause the equilibrium to shift to the right? When we add a catalyst that affects both reactions the same way, adding more PCl5, so now we have more of the products that is going to shift towards the reactants. That's a reverse reaction. So the opposite of what the question is asking. So right means there will be more forward reaction. Increasing the pressure. So remember, when you increase the pressure, it will work in this case because they're all gases. The reaction shifts towards the side where we have more moles. So because you have more moles on this side, here you have 2 moles, here you only have 1 mole. So this is correct. And when you increase the temperature, in that case, the reaction favors the endothermic reaction. Sorry, my bad. When you increase the pressure, the reaction shifts towards less moles because now you have less space. So increasing the pressure means less volume, so that means it shifts towards less moles. So your option is not 3, it's going to be 4. Because when you increase the temperature, that favors the endothermic reaction. So increasing the temperature of the system causes the concentration of which thing to increase. So once again, it favors the endothermic reaction, which in this case is the reverse reaction. So that means we are producing more of HI. So HI will increase. Which statement describes ice and liquid water in a stoppered flask at 0 degrees Celsius? So this is what we refer to as the phase equilibrium. So the rate of, because there's a phase change going on and it's going on at the same rate. So the rate of melting must equal the rate of freezing. The rate of freezing must be greater than the rate of melting. So remember, if it's at equilibrium, then the rates must be equal. What occurs when sodium sulfate solid is added to the system, increasing the concentration of the sulfate ion? So if you have more of the sulfate ion, then the reaction shifts towards barium sulfate. So you can say that the reaction shifts to the left and the concentration of barium is going to decrease because we are using more of barium to produce more barium sulfate. Which equation represents a physical equilibrium? So physical equilibrium would mean when we don't have a chemical reaction going on. So this could be something like a phase change. So here we have solid breaking into ions, which is kind of like the bonds breaking. So that is not your answer. Then you have these two things reacting to become a compound that is not phase. It's a chemical change. Sorry, it's not physical, it's a chemical change. Then you have O2 converting into O3, that is once again chemical. So the answer will be nitrogen going from liquid to gas and then from gas to liquid. So based on table G, with solute sample in 100 gram of water at 40 degrees Celsius can produce a solution equilibrium in a closed container. So this is going to be based on table G. So just one quick thing that I wanted to mention here. A solution equilibrium is when we make a saturated solution. So go ahead and use your table G to figure out which one is going to be a saturated solution, and that is going to be your answer. So explain in terms of the rates of reaction, what happens when this reaction reaches equilibrium. So you just have to say the rate of the forward reaction is going to be equal to the rate of the reverse reaction. Then state in terms of the moles of gases why the equilibrium shifts to the right due to an increase in pressure on the system. So when you increase the pressure, that means we now have less volume. So the reaction shifts towards less number of moles. So that means, which is why in this case it's going to shift towards the right because in your reactants you have 4 moles, and in your products you only have 2 moles of the substances. So state in terms of both the frequency and forces of collisions, what would result from decreasing the temperature of the original sample at constant volume. So when we decrease the temperature, you can say that that decreases the average kinetic energy. So that means that decreases the frequency of and the force of the effective collisions. Now let's move on to acids, bases, and salts. Which formula is an electrolyte? So electrolyte is something that can conduct electricity when it is in a solution. So something that can break into ions. So H2O is just water, covalent molecule or molecular compound, doesn't break into ions. CCl4 is both nonmetals, once again covalent. H2SO4 can actually break into 2 hydrogens and a sulfate, and that is because although hydrogen is a nonmetal, H2SO4 is an acid, and acids can split into ions. So this one can conduct, and then C6H12O6 is also covalent. So your answer here is an acid. Which formula represents an Arrhenius acid? So Arrhenius said that an acid is something that breaks into hydrogen or hydronium as the positive ion. So we are looking for something that can produce hydrogen ion. So that will be HCl3. According to one acid-base theory, this is whenever it is one acid-base theory, we are most likely talking about Bronsted-Lowry. And acid is a substance that, so remember the bad, that means base accepts, acid donates. So, and we are always talking about the proton, the H positive ion, never about the hydroxide. So an acid is the thing that donates the hydrogen ion. Arrhenius base is the one that results in the production of hydroxide. So you're looking for something that can produce hydroxide. This right here is actually an acid, and you can verify that using table K. So the pH value of a solution is changed from 6 to 4, which phrase describes the change in the hydronium ion concentration. So remember that when the pH increases, the hydronium ion concentration decreases, because now we are going more towards a basic solution, and vice versa. So if you're in this case, the pH is going down, that means hydrogen should go up. So decreasing is not an answer. So, but increase by what? By a factor of 2 or by a factor of 100? So the answer here is that our pH is the one that is decreasing 2 units, but hydronium ion concentration is increasing by a factor of 100. In this system, the H2O liquid acts as, so if you look at H2O, looks like your NH3 is accepting a proton. So when something that accepts is going to be the base, and your H2O in this case is converting into OH, so that is going to be the acid because it's donating. So once again, remember bad. Base accepts, acid donates. So H2O in this case is an acid because it donates. Which indicator is blue in a solution that has a pH value of 7? So you're just going to have to use table M. So the pH range for Brome Crescel Blue is, oh, no, sorry. The first one is Brome Crescel Green, is 6 to 7. So because 7 is in the middle between yellow and blue, so that's going to be green. So it's not Brome Crescel Green. Then we have Methyl Orange, pH range is 3.1 to 4.4. So when it's 7, it's going to be yellow. Phenolphthalein, when it's 7, it's going to be colorless. And Thymol Blue, the pH range is 8 to 9.6. So when the pH is when the pH is 7, Thymol Blue is going to be yellow. Interesting. This is not a good question. It should not have said blue. Oops, apologies. I read Brome Crystal Green wrong. The pH range for Brome Crystal Green is 3.8 to 5.4. So when the pH is 7, it is going to be blue. So that's your answer. So which equation represents a neutralization reaction? So remember, neutralization is when you combine an acid and a base and it produces water and salt. So you're looking for an acid and a base in your reactants. So 1 and 2 is not your answer. So here we see a base, here we see an acid, and then I see water, and then I see salt in my answer. So that's your answer. Which aqueous solution has the greatest ability to conduct an electric current? So first of all, we can go ahead and cross out glucose because that's covalent. So for sodium chloride, we have to compare the concentrations. Remember, the higher the concentrations, the more ions there are. So the stronger of an electrolyte it is. Which formula can represent hydrogen ions in an aqueous solution? So that will be H3O positive, because when hydrogen combines with water, it produces H3O positive. As more NaCl is dissolved in dilute unsaturated sodium chloride solution, the conductivity of the solution. So when we have more ions, the conductivity increases because the ion concentration increases. So there's more movement. So how many milliliters of 1 molar HCl must be diluted with water to make exactly 500 milliliters of 0.1 molar HCl? So this is a molarity question. However, here, this is kind of also a solutions question, but we are not just calculating the molarity of one thing. We have to use the equation that we used for titration. But instead of saying molarity of acid and molarity of base, we'll just say M1V1 equals M2V2, because we are starting with 0.1 molar solution. Sorry, no, we are starting with a 1 molar solution. And we want to figure out how much volume of that do we need to make a 0.1 molar solution of HCl and exactly 500 milliliters of that solution. So you just do the math, solve for x, and get your answer. So that should be, I believe, about 50 milliliters. So according to one acid-base theory, once again, Bronsted-Lowry, most likely, which pair are the H-positive donors? So here's what we mean by pairs. Remember the conjugate acid-base pair? So conjugate acid-base pair. So what's happening here is that NH3, if you look at NH3, it looks like NH3 is accepting the proton in the forward reaction. So this is the base if it's accepting, but NH4 is going to be the conjugate acid of that base, and then H2O is going to be the acid because it's donating, and this right here is going to be the conjugate base. So when the question is saying which pair is accepting, that means we are looking for an acid and a conjugate acid. So H2O is the one that's accepting in the forward, H2O is the one that's donating in the forward reaction, and H4 positive is the one that's donating in the reverse reaction. So your answer is this. State the color of Brome Crystal Green indicator if it were added to the sample of the 0.1 molar potassium hydroxide. So the first thing that we want to do here is calculate the pH. So 0.1 molar is actually 10 to the power of -1. So this gives us the POH because we are looking at a base. So POH of 13, POH of 1. That means the pH is 13. So Brome Crystal Green is actually going to be blue at a pH of 13. Determine the concentration of HCl sample using the titration data. So you just have to use the MAVA equals MBBB equation. Compare the hydroxide ion concentration of the 0.1 molar KOH with the hydroxide ion concentration of the resulting neutral solution. So remember, if the resulting solution has a higher concentration, then that means the hydroxide ion concentration is higher. Identify the liquid tested by the student that is most acidic. So most acidic means the one that has the lowest pH. So that will be lemon juice. Lowest pH. Complete the equation by writing the formula of missing product in the reaction of aqueous potassium hydroxide. So potassium hydroxide is KOH plus vinegar or acetic acid. So you can always go to table K or L to find the formulas for your acids and bases. So acetic acid is actually CH3COOH. So to make water, base is going to give its hydroxide, acid is going to give its hydrogen. So that will be H2O. And then whatever is left is going to be CH3COO. And then K, the reason why I'm writing potassium at the beginning is because it's an acid, it's a metal. We always write metal first. So there you go, that is your salt. Explain in terms of ions why the hydrochloric acid solution can conduct an electric current. So you'll just say because the ions dissociate and move in the solution. So dissociate and move. Compare the number of moles of hydrogen ions to the number of moles of hydroxide ions in the titration mixture when HCl is exactly neutralized. It should be the same number of moles. So moles of H positive are equal to the moles of hydroxide. Determine the pH value of a solution that is 10 times less acidic than a 0.01 molar HCl. So for a 0.01 molar HCl, which is 10 to the power of -2, the pH is 2. If we are looking for something that is 10 times less acidic, then that means we are looking for something that has a pH of 3. Which statement describes an electrolyte? So electrolyte is something that can conduct electric current when it is in a solution, so not as a solid. It dissolves in water. The resulting solution conducts an electric current. There you go. And which type of reaction occurs when an arrhenius acid reacts with an arrhenius base? That is your neutralization. Now let's talk about your redox reactions. So which metal is most easily oxidized? So in this case, you can simply go ahead and use table J to compare the ones, compare their reactivities. The one that is most active is going to be most easily oxidized. Which statement describes the electrons involved in this reaction? So we see that zinc is going from a charge of 0 to a charge of +2. That means zinc is losing electrons. So each zinc atom loses 2 electrons, and each cobalt atom in this case is gaining those 2 electrons. So zinc loses 2 and cobalt gains 2. What are the 2 oxidation states of nitrogen in NH4NO2? So the easiest way to solve a question like this, where you have 2 polyatomic ions, is to think about their individual charges. So ammonium has a charge of +1, and nitrite has a charge of -1. So that means when you set up the equation for this, nitrogen is X, hydrogen is +4 for the 4 hydrogens, and that should be equal to +1. So when you're solving for X, this should be 1 minus 4, that is -3. And then for the second one, this is X minus 4, because each oxygen is -2, and that should be equal to -1. So -1 plus 3, that's +3. So your answer is 3. -3 and +3. So oxidation number of copper changes from, so copper in this case is going to be, if you do the anti-crisscross, so copper is +2, and then copper in the products is 0. So it goes from +2 to 0. When a sample of magnesium reacts completely with oxygen, the magnesium loses 5 moles of electrons. How many moles of electrons are gained by oxygen? It should be the same. That's how redox reactions work. The electrons gained are equal to the electrons lost. Which statement describes the reactions in an electrochemical cell? So the oxidation is always at the anode and the reduction is always at the cathode. So remember the acronym that we used for this, NOx and red cat. So oxidation at the anode, reduction at the cathode. Which particles are transferred during a redox reaction? That is your electrons. Which process can be represented by a half reaction equation? So out of all of these could be oxidation. Based on table J, atoms of which metal will lose electrons to the calcium ions? So we are looking at something that is more active than calcium. So just go to table J, look for the option that is more active than calcium. Which equation represents conservation of charge? So that means the equation where charge is same on both sides. So for example, if you look at 1, the overall charge on this side is 0. That means the overall charge on this side should also be 0. But what I see here is -1 and -2. That adds up to like -3. So it's not the same. So if you compare both sides, look for the side that is the same on both sides. It looks like option 3 is the one that is balanced. So when comparing voltaic cells to electrolytic cells, oxidation occurs at the anode always in both type of cells. Which statement describes the two types of reactions that occur in operating electrochemical cells? So we have spontaneous in voltaic and non-spontaneous in electrolytic. So here you go. Which process is represented by this diagram? So this is an electrolytic cell, and an application of that is electrolysis. So that is the dissociation of something, of a compound, into its individual ions or elements. So based on table J, which ionic equation represents a spontaneous reaction that can occur in a voltaic cell? So all you have to do is once again compare that if iron is losing in this case and magnesium is gaining, is that possible? Can iron lose? So iron can only lose to magnesium if iron is more active. If iron is less active than magnesium, then it's non-spontaneous. And then here we see electroplating. So identify the electrode that attracts the copper ions as the cell operates. So because this is your copper electrode, let's first identify your anode and cathode. So remember, in case of an electrolytic cell or in electroplating, the thing that is getting electroplated is always your cathode. And the other thing is always your anode. So remember, oxidation occurs at the anode, so that means this is going to lose the electrons, and this thing is going to gain the electrons. So once it gains the electrons, it attracts the copper ions from the solution. So to answer this, you can say your cathode is going to attract the copper. So determine the oxidation state of sulfur in copper sulfate. So you can, if you just do the anti-crisscross, or if you just figure out the charges, because now you get +1 and -1, but sulfate is a polyatomic ion and it has a charge of -2, so that means copper in this case is +2. Write a balanced half reaction that occurs at the cathode here. So remember, we do not need to worry about what the bracelet is made of, because nothing's happening to that material. Copper is getting oxidized at the anode and it's getting reduced at the cathode. Okay, so we'll just say, write the equation for the reduction of copper. So reduction means something is gaining electrons. So we have copper that is gaining the electrons on the cathode, and it's converting into the copper metal, which is getting deposited on the bracelet. Identify the subatomic particles that flow through the wire as the cell operates. So that is your electrons. And what is the direction of the flow? So remember, in this case, the electrons always go from anode to cathode. So in this case, they are going to go from, we are comparing copper and iron. So compare which one is more active. So out of copper and iron, iron is more active. So the electrons are going to go from iron to copper. So based on the change in intensity of the color of the copper nitrate solution, explain what happens to the copper ions as the cell operates. So what's going to happen here is electrons go from iron to copper. And so because iron electrode is going to lose electrons, it also loses the iron ions in the solution. And the copper electrode is going to get the electrons, and those electrons are going to attract the copper ions from the solution. So when that happens, copper gets deposited on the copper electrode. So copper deposits on copper electrode, and the mass of the copper electrode increases. Then state the purpose of the salt bridge. So remember, some people always get this wrong. The purpose of your salt bridge is to neutralize the solutions. And the way the salt bridge does that is by allowing the migration of ions, or the movement of ions. So even if you only say neutralize the solution, that should still be fine. So write a balanced half reaction that occurs at the copper electrode. So as we just said, at the copper electrode, we have copper ions that are combining with electrons, and they are becoming copper metal. Explain in terms of electrical energy how electrolysis reactions differ from voltaic. So because it says in terms of electrical energy, make sure you do not forget this. So you just have to say in voltaic, we go from electrical energy to, sorry, the other way around. In voltaic, we go from chemical energy to electrical energy. And in electrolytic, we go from electrical energy to chemical energy. Please don't write it like this, like write complete sentences. I'm just trying to go quick. Okay, using the results of the student's investigation, state evidence that zinc metal is more active than copper. So what you see here is that we have different solutions in each of the wells, and then we are putting the metals in those wells. So when you put copper in the magnesium solution, in the zinc solution, in iron solution, and in copper solution, nothing happens. That means copper is not reacting. But when you put zinc in the magnesium, zinc, iron, and copper solution, it doesn't react with two of them, but it does react with the other two. So you can say the evidence here is that copper does not react with any solution, but zinc reacts with iron and copper. So that's your answer. Right, let's talk about organic chemistry. So based on table R, which functional group allows a compound to be classified as an organic acid? So very easy question. Just look at table R, look at the functional group of the organic acid. So that should be this one. Atoms of which element bond to one another in chains, rings, and networks? That is carbon. And this is the most basic question for organic chemistry that no one should get wrong. one element that makes up organic chemistry is carbon. Okay, carbon is the most important thing in organic chemistry. If an element doesn't have carbon, it's not organic. So hydrogen, oxygen, and nitrogen, they are also sometimes present. Hydrogen is mostly always present with carbon, but the foundation of organic chemistry is carbon. So you can't just say hydrogen when the question is asking, what is the evidence that this compound is organic? You must say carbon. So which formula represents a hydrocarbon? So as the name indicates, we are looking for something that has hydrogen and carbon only. So that is only the first one. Then what is a chemical name of this compound? So we see that this is a branched hydrocarbon. I only see carbons and hydrogens. So we have 1, 2, 3, 4, 5 carbons in the parent chain. So the name of the parent chain should be pentane, because pent means 5 carbon. So 1 and 2 is not your answer. And then I see one branch at carbon number 2 and one branch at carbon number 3. Remember the reason why I am not naming this the other way. So if I name it this way, then I'll have my first branch at carbon number 3. But we want to name it from the direction that brings us to the first branch faster. So this should be a branch at carbon 2 and 3, but which branch? Because we know that this is a methyl branch because it only has one carbon. So 2 methyl branches, one at carbon 2, one at carbon 3. So that should be 2,3-dimethyl pentane. This is not an ethyl because ethyl means, ethyl would look something like this. Okay? So ethyl means you have 2 carbons in the same branch. So which name represents a hydrocarbon? So once again, if you see any other prefix or suffix that points towards any other type of organic compound, then that means it's not a hydrocarbon. Your answer is 1, but if you look at the second one, you see iodo, which means you have a halogen here, so it's not just a hydrocarbon. Here this ends with -one, so that's a ketone. So it should have an oxygen, and then you have an -ol, so that is an alcohol. So this also has an oxygen, so not just a hydrocarbon. At STP, propanol and propanone have different chemical properties due to their different so molecular masses, maybe not, because they do have the same prefix, and maybe they have similar chemical formulas. Percent compositions, we don't know because we are not given any formulas. Empirical formulas, same thing. So functional groups, we know they have different functional groups for sure because of these prefixes. One of them is an aldehyde, the other one is a ketone. What statement describes the bonding in an alkyl molecule in an alkyne molecule? So alkyne means something that has a triple bond between carbon atoms. There's at least one carbon to carbon triple bond. Structural formula differs from a molecular formula in that a structural formula shows the arrangement of the atoms, not just the number of each atom. So which compound has a functional group that contains 2 oxygen atoms? So amine, our options are amine, chloropropane, which is just a halide, so that cannot have oxygens. Then we have an ester, and then we have an ether. So an amine does not have any oxygens. It just has a nitrogen, and so that is not your answer. The ester does have 2 oxygens, one that is double bonded, the other that is single bonded, and ether only has 1 oxygen, so that is not your answer. An atom of which element is bonded to the carbon atom in the amide functional group? Once again, all of these questions you can get their answers from table R. Okay, you don't have to memorize these things. So an atom of which element is bonded to the carbon atom in the amide functional group? So in this case, you do have a nitrogen. There's also an oxygen in amide, but that is not an option. Which formula represents a saturated organic compound? So saturated means something that has So saturated is something that has only single bonds between the carbon atoms. So if you try to draw these, the first one has 2 carbons and only 2 hydrogens. So in this case, in order for each carbon to have 4 bonds, they need to have a triple bond among themselves. The second one also has 2 carbons but 4 hydrogens now, so they should have a double bond. The third one has 3 carbons and then we have 4 hydrogens, so maybe one of them has 2 hydrogens but the other 2 only have 1 hydrogen. So this one right here, interesting, that won't work. So that means this is actually an example where one of them has 3 hydrogens and there's a single bond here and there's a triple bond right here. And then for the fourth one, we have carbon, 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 and 8 hydrogens. So now we have 1 hydrogen, or now we have the maximum number of hydrogens with each one. So, sorry, saturated means single carbon-carbon bonds. The compounds, these two have different what? So let's write their molecular formulas first. In the first one, we have 1, 2, 3 carbons, and then 1, 2, 3, 4, 5, 6, 7 hydrogens, and only 1 oxygen. In the second one, we have 1, 2, 3 carbons, we have 3, 4, 5, 6, 7, 8 hydrogens, and then we have 1 oxygen. So do they have different number of carbon atoms? They don't. Do they have different number of hydrogen atoms? Yes, they do. Do they have different functional groups? Looks like they do. Did I miscount any hydrogens? 1, 2, 3, 4, 5, 6, 7. Oh yeah, there should be 8 hydrogens. So they have same number of hydrogens. They just have different functional groups. Molecular masses are going to be the same because formulas are the same. So here's how we know that they have different functional groups. If you try to draw out the first one, this one, we see that we have CH3, then we have a carbon with 2 hydrogens, then we have a carbon with 2 hydrogens, and then we have an OH. If you look at the second one, now we have, let me just do that here. So now we have CH3, then we have an oxygen, and then we have CH2, and then we have CH3. So as you can see, the oxygen is at a different location for both of them. So this right here is an alcohol because it has the OH, and this right here is an ether. Okay. So what type of reaction is represented by the equation? So here we see that we have this hydrocarbon. Let's draw this out. So 1, 2, 3, 4 hydrogens, and we only have 4 carbons and 10 hydrogens. So let's try to give them maximum number of hydrogens first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. So this is your saturated hydrocarbon that is combining with the chlorine, and then we see that there is 1 hydrogen leaving, and a chlorine is taking its place, and then we are also forming an acid. So this type of reaction is a substitution. What type of organic reaction produces carbon dioxide and water? So this is actually your combustion, which is something that a lot of people forget. But remember, combustion is an organic reaction because we start with a carbon-based compound that reacts with oxygen to produce carbon dioxide and water. So what is the molecular formula of this compound? So we just have to add carbons and hydrogens. So we see 3 carbons and 1, 2, 3, 4, 5, 6 hydrogens. So that should be C3H6. Which equation represents fermentation? So fermentation is when we start with some sort of sugar and it converts into an alcohol and carbon dioxide. So that is this example right here. You must memorize these equations for the organic reactions. So which term represents an organic reaction that produces soap? That should be saponification. Which formula represents an isomer of this compound? So isomer means something that has the same formula. So this right here has the formula of C3 H 1 2 3 4 5 6 7 8 and 1 oxygen. So we are looking for something that has same formula. So let's write the formulas of everything else. So we have 3 carbons in the first one, 8 hydrogens and 1 oxygen. So this is an isomer. And just so you all know, let me also write the formulas of the rest of them. So we have C3H6O, and then we have C3H6O2, and then we have C3H6O again. So these two can actually be isomers of each other. So what type of reaction does this equation represent? So we see that we are reacting an organic acid, COOH represents an organic acid, and an alcohol. So this is actually esterification. So identify the element present in the reactants that allows them to be classified as organic compounds. So the question that I mentioned earlier, the one element that makes them organic is carbon. Please don't say anything else. Draw the structure and write a chemical name for reactant number 1, so that if we draw that out, we have CH3, then we have a carbon. And remember, whenever you see 2 oxygens written like this together, that means one of them is double bonded to oxygen, the other one is single bonded, and then there's just hydrogen. So this functional group right here represents that this is an organic acid. So you can get help from table R if you forgot how to name organic acids. So to name organic acids, we just need to start with a prefix for the number of carbons. We have 2 in this case, so that should be eth. And we end that with anoic acid. No need to put a number because this functional group is always at the end. For reactant number 2, I see CH3. So 1, 2, 3, then we say CH2, and then we see OH. So this right here is an alcohol, and we know that because of this OH. So to name alcohols, we once again start with the prefix, and then we end that with -ol. One thing with alcohols is that we do add the location actually, because the OH is not always at the end, and you can verify that using table R. Identify the products, draw the structure, and write the chemical name. So because this is esterification, what's going to happen is that the OH, actually the hydrogen from the organic acid and the OH from the alcohol are going to combine to make water. So one of your product is going to be water. And the second product is actually going to be everything that's left. So if we write that, we have CH3C with double bonded oxygen, and it has 1 oxygen left here. And then we are going to combine the 2 carbons. So CH2 and CH3. So this is your ester. And when we are naming the ester, there are 2 parts. First, we name the branch that is connected to the single bonded oxygen. So this branch is named with a YL, and because it has 2 carbons, so this is going to be ethyl. And then we go ahead and we name the carbons that are bonded with the double bonded oxygen. So because we have 2 of them, so that should be eth, and then we end it with this with NO8. Now draw a structural formula for 3-ethylhexane. So the first thing that we can do is draw the parent chain. So we know we have 6 carbons in the parent chain because we have the prefix hex. And they're all single bonded because it ends with ane. And then the ethyl represents a branch at carbon number 3. So 1, 2, 3 at carbon number 3 we can make a branch, and this branch has 2 carbons because the prefix of the branch is eth. And then just go ahead and put your hydrogens. Remember, each carbon should make 4 bonds. So based on that, just decide how many hydrogens each carbon needs. Explain in terms of molecular formulas and structural formulas why 1-butene is an isomer of 2-butene. So when you answer this, you are going to say, because it says in terms of these things, so you're going to say they are isomers because they have same molecular formula with different structural formula. So in one of them, the double bond is at carbon number 1. In the other one, the double bond is at carbon number 2. Okay, so you'll just say same molecular formula, different structural formula. That's it. Draw a structural formula for the missing product X. So this right here is actually going to be your addition reaction. What's going to happen is that the double bond breaks and the 2 hydrogens are going to be added to this compound. So that will be CH2, C, and then this C, and then CH3. So this is after the double bond breaks. Now remember, we have that 1 electron left on each carbon, so the 2 hydrogens can come in and take that place. Try your best to include the hydrogens, especially if you have time, which I'm sure you will have a lot on the Regents exam, just so no one has any reason to take any points off. Alright, so draw a structural formula for the missing product X. We just did that. Moving on, explain in terms of bonding why the hydrocarbon gas used in the cutting torch is classified as an alkyne. So we are talking about this thing right here. So when we draw this out, we only have 2 carbons and 2 hydrogens. So because each carbon must have 4 bonds, we should have a triple bond. So when you answer this question in terms of bonding, you'll say there is a triple bond between carbon atoms. So triple bond between carbon atoms. And then if we have to draw the structural formula for methanol, so the prefix right here indicates that this is an aldehyde. Once again, use table R if you don't know. And then the meth means we only have 1 carbon in this aldehyde. So we are just going to go ahead and draw that 1 carbon, and then we are going to draw the functional group for aldehyde. So that is a double bonded oxygen and a hydrogen. Determine the number of carbon atoms in one molecule of an alkane that has 22 hydrogen atoms in the molecule. So we are looking at an alkane. What you can do is you can use table Q, which is the homologous series of hydrocarbons. The general formula for an alkane is CnH2n plus 2. So in place of N, we can go ahead and actually not in place of N, we can kind of try to figure out that if we want to change this formula and make this 22, so if we have 2 here, and so that's 2 of the things, we are left with 20 hydrogens. So if we multiply this with 10, that will be 20 plus 2, 22 hydrogens. That means we should ideally have 10 carbons. So your formula will be C10H22. Right. Finally, let's talk about nuclear chemistry. So compared to the energy that is released per mole of reactant during chemical reactions, nuclear reactions produce much greater energy, which phrase describes a risk of using the radioisotope cobalt-60 in treating cancer. So production of acid rain or greenhouse gases, they have nothing to do with treating cancer. Or the ozone depletion has nothing to do with treating cancer. So it's just increased biological exposure. Which type of reaction is represented by each of these equations? So these are the most common examples of fission and fusion, because these are kind of the only examples of fission and fusion that we know of. with fission, we also have successful fission with plutonium besides uranium. So whenever you see these equations, they remember that they represent fission and fusion. So equation 1 is fission and equation 2 is fusion. Number 4, which nuclear emission has the least penetrating power and greatest ionizing ability? So least penetrating power means we are talking about the one that has that can go through the least amount of stuff. So we know that that is the alpha radiation or alpha particles. And then greatest ionizing ability means it has the greatest charge. So if you compare the charge of everything in the table, it's going to be alpha particle is the one that has the greatest charge. Which nuclear equation represents spontaneous decay? So spontaneous decay is the one that only has one reactant. So if you look at all of your options, this one has 2 reactants, 2 reactants, 2 reactants, so only one. That is your answer. Which symbol represents a particle that has a mass approximately equal to the mass of a neutron? So a neutron has no mass, so the only radiation that has okay, sorry, I mixed that with the electron. So neutron has a mass of 1. Neutron and proton, they both have a mass of 1. Electrons have a mass kind of equal to 0. So we are looking for something that has a mass equal to 1. So beta has a mass of 0, alpha has a mass of 4, proton is the one that has a mass of 1. In which reaction is an atom of one element converted into an element of another element? That is the definition of transmutation. So we either have natural or artificial. Natural is when it's spontaneous, artificial is non-spontaneous. Some examples are fission and fusion. Which radioisotope requires long-term storage as the method of disposal to protect living things from radiation exposure over time? So we are looking at something that needs to be stored so that we are not exposed to the radiations for a longer period of time. That means this is something that has a very long half-life. So you can go to table N, where you are given the half-lives of radioisotopes and find the one that has the longest half-life. Which statement explains the energy term in this reaction? So what they're trying to ask is, where is the energy coming from? So remember we said that some of the mass is converted into energy. So that is option number 3. Mass is lost due to the conversion of mass to energy. Which statement describes the benefit of using fission reactions? So fission reactions do produce radioactive waste that must be stored, but that's not a benefit. Nuclear fusion consists of stable isotopes. No, they don't. Gamma radiation is produced sometimes. Large amounts of energy are produced. So this is one benefit, that it does produce significant amount of energy that can be beneficial. Which emission causes the atomic number of a nuclei to decrease by 2 and its mass to decrease by 2. So this charge and mass matches with the alpha particle, which this equation represents. So remember, you see hydrogens making helium, so that is your fusion reaction. Identify the decay mode for neon 19. Remember, go to table N to answer this question. Explain in terms of half-lives why radium-226 may have been used more often than the other radioisotopes in these paints. So you can go ahead and compare the half-life of radium-226, radium-228, and I wonder if you have this isotope in table N. But even if you don't, and even if you can only compare this with radium-228, that is fine, because you can say that the reason why, or you can just make your decision based on that. So let me try to find that very, very quickly. Oh, never mind. Wow, how did I miss that? Your half-lives are given right here, so you don't need to go to table N. Whew, I'm tired, folks. I'm tired. Okay, so as you can see, there's a significant difference between the half-lives of radium-226 and the other two. So, reason why we're using this one is because it has a longer half-life, so it helps more. So complete the nuclear equation for the beta decay of PM147. So PM147, the first thing that we want to do is find the atomic number of this element. So that should be 147, about 61. And then they already told you that this is going to be a beta decay. So beta has a mass of 0 and a charge of -1. So now you just do the math. So 147 minus 147 minus 0, that gives you 147. And then 61 minus -1, that gives you 62. And the symbol for this element is Sm, the element that has an atomic number of 62. What fraction of an original radium-228 sample remains unchanged after 17.4 years? So after 17.4 years, the first thing that you want to figure out is how many half-lives have passed. So we know that one half-life for radium-228 is 5.8. So 17.4 is about 3 half-lives. So that means if we started with a sample of 1, after the first half-life, we had 1/2 of that sample left. After the second half-life, we had about 1/4 left. And after the third half-life, we had about 1/8 left. So this is the fraction that is left. Based on table N, determine the total time required for an 80-gram sample of cobalt-60 to decay until only 10 grams of the sample remains unchanged. So we went from 80 grams to 10. So let's figure out how many half-lives have passed. So after the first half-life, we went to 40, then to 20, and then to 10. So that is in total 3 half-lives. And so we want to figure out how much time it took for 3 half-lives. So 1 half-life of cobalt-60, according to table N, is about 5.271 years. So if we had 3 half-lives, we just multiply with the 3. Determine the time required for a sample of cesium-137 to decay until only, I believe that is 1/8 of the original sample remains unchanged. So 1/8, first thing we want to figure out is how many half-lives is that. So before 1/8, we actually had 1/4. Before 1/4, we had 1/2, and before 1/2, we had 1. So that means we are done with about 3 half-lives in this case. So if 1 half-life of cesium-137 is 30.2 years, then the time that we need to only have 1/8 of the sample left will be 3 times of that. Complete the nuclear equation in your answer booklet, which you don't have, for the decay of cesium-137 by writing a notation for the missing product. So cesium-137 has a decay mode of beta negative. So that is beta particle, the mass of 0, charge of -1. The atomic number of cesium is 55. So 137 minus 0 is 137, and 55 minus negative 1 is 56. So that is barium. And here we are talking about tritium, which is an isotope of hydrogen with a mass of 3. Complete the nuclear equation for the decay of tritium by writing a notation for the missing nuclide. So hydrogen with a mass of 3 and an atomic number of 1. According to table N, when tritium decays, it once again produces a beta particle. So that is 3, and 1 minus negative 1 is 2, and that produces helium. So based on table N, identify a nuclide that has the same decay mode as tritium but has a longer half-life. So we are looking for something that has a beta negative decay mode but much longer half-life. So that could actually be cesium-137 that we looked at earlier. Here we've got 3 equations. State the neutron to proton ratio for an atom of iron 58. So first of all, let's calculate how many neutrons we have here. So the atomic number of iron is 26. So 58 minus 26 is about 32 neutrons. So the ratio is going to be 32 neutrons over 26 protons. So that is about 1.23. State in terms of elements why equation 2 represents a transmutation reaction. So because it says in terms of elements, so you have to say that one element or the isotope of one element is converted into the isotope of a different element. So isotope of one element converted to isotope of a different element. Identify the particle represented by X in equation number 3. So let's do the math. So we can do 60 minus 59. That should be about 1 here. And it's about 0 at the bottom. So we are looking for if the atomic number is 0, this is definitely not an element. So if we look at our decay particles, one that has a mass of 1 and a charge of 0, that turns out to be a neutron. So the answer here is a neutron. And compare the amount of energy released by the fission of 1 mole of uranium to the amount of energy released by the combustion of 1 mole of octane. So remember, fission is a nuclear reaction, combustion is a chemical reaction. So the energy released by fission is much greater than the energy that is produced by combustion. And there you go. Those were some of the most common questions that have showed up on the Regents exam. Good luck for your exam, and I hope to see you next time.